Hello everyone, welcome to Global AI Bootcamp Bulgaria. We are doing this event for the first time fully online and we have really amazing list of speakers. We will start after a few minutes with the first presentation from Albert and really I would like to say a big thank you to our team, especially to Stefka, who is able to arrange most of the thing around streaming and organization, and all our speakers who are really best expert and also volunteers for this event. And I think that you will have really nice event. Uh, Probably we will have one more boot camp at the end of the year, and we will have one big AI conference, which for now is scheduled for March, but probably we will make it during the summer because of the situation with pandemic. So thank you very much for coming and enjoy the conference.
So thank you everyone for being here today. I hope you all are having a good day. So I'm El Troteboer. Today I will be talking about how we can build smarter solutions using Azure and cognitive services. So what I'm going to talk about today is basically how we can bring in cognitive services and actually do more with less code, with less configuration. So first of all, I would like to say thank you to the partners, Microsoft in this case, because still we need these partners to do these kind of events. So a little bit by myself, I'm El Troteboer. I come from the Netherlands, where I work at a company called Motion 10. At Motion 10, basically what we do is everything Microsoft. So we focus on data analytics, apps infra, modern workplace. And myself, I'm working there as a cloud solution architect. So I'm working all day with different clients to do these kind of implementations and make sure they have the best solutions. I'm also an Azure MVP, so I love working with the community. So that's also why I'm here today, of course. So I do a lot of speaking, blogging, I organize my own events. So thank you for having me here today because I love working with the community and this is all I'm doing all this for you. If you want to reach out to me, I'm always available on Twitter. So if you have any questions, any remarks, please just let me know and I will always respond to you on here. So with that, let's go to have a look at cognitive services. But before we look at the cognitive services, we first have to understand what is cognition. So cognition is about acquiring knowledge and understanding through thought, experience, and senses. So basically, we acquire knowledge, we understand things because we see things, hear things, feel things, and we can then make thoughts around this like, what is this doing and why is this doing this? So cognitive services are APIs that do this. So cognitive services are basically artificial intelligence. So it's not us as people, but it's APIs instead that do the same cognition, like they see things, they hear things, they speak, they understand, all in this natural way as we do as well. So just by looking at things, by hearing things, they understand what's happening and are making decisions and action on top of that. So let's have a few examples of different cognitive services in the real world. And these are all real-world applications, like you might be using this today already. For example, if we look at vision, you might be saying, okay, I want to upload a picture and I want to know what is in this picture. In this case, there's different people in there. We can recognize there's 5 faces in there. We can see that there's no moderated content in there. We can see which colors are in there. So basically we can tell about this picture, we can see, okay, like what is in this and what is happening here. So this is what vision is about, looking at something and determining what is in there. Speech is about saying something. So speech might be saying, okay, I want to go to a restaurant. Bing, please take me to the next restaurant. And then Bing coming up saying, okay, you want to find a restaurant, I will look this up for you. So this is about speaking and actually talking to my application, saying, okay, I want to do something with this. Language understanding is about understanding what I'm trying to do. So I might say, okay, play today's customer call recording. Language understanding will know that, okay, I'm trying to play a call. It knows which customer I'm talking about. And it also knows that it's about today's call. So it understands from what I'm saying. So this might be typing, this might be speech to text, but it understands what I'm trying to do and does that action for me. Knowledge base is about saying, okay, I want to know something. So in this case, I might be saying, okay, I want the top publications of customer lifecycle trends. It will then come back to me with those top results about these customer lifecycle trends. And if you are using Word, you might already know about this. Like in Word, when you need some more information, from in Word, you can actually say, okay, give me more information about this topic. And we'll just pull in the information into Word for you and give you all this information right where you need it. And finally, searching. And we are all doing this, whether it's Bing or Google or whatever, but you are searching for something. Like in this case, I want to search for fraud prevention. And in this particular case, we are actually looking to the news. So we are looking to all the news article with Bing, and we are seeing, okay, what is there about fraud prevention? And you can actually do this within your own application. So you can bring all these different kind of services into your own applications and actually use this to build better and more smart applications and solutions. If you want to get started with AI yourself and with these cognitive services, I would say have a look at the Intelligent Kiosk. The Intelligent Kiosk will actually allow you to find out about all these different cognitive services with sample applications and just get started very easily, very quickly, just by providing your own API keys, actually doing all these things with different samples. So this might be something like uploading your picture and seeing what if you're happy or sad. It might be something like real-time crowd insights over here, which means that you actually have like a camera on top of your audience and see how people are reacting. It might be something like a visual search, like just searching an image and finding related images. So all these different samples you can get started with quite easily and just see how things might work to get some information about what you might be doing with these services. And of course, we are talking about Azure Cognitive Services. So we are going to look at the different cognitive services within Azure. So first of all, we have the Decision API. And this is all about logical decision making, saying something happened and checking what you want to do next. We have the Language API, the Language Cognitive Services. And this is all about natural language, typing something and actually understanding what you are typing. We have the Speech Service, and this is of course about the spoken language, me saying something and this understanding this, translating it or something like that. The Vision API, which is about everything we can see. So I might upload pictures or videos and to actually understand what is happening there and bring this back to me. And finally, Web Search is about everything we can search and look up. So let's have a quick look at those the different services. First, we have the decision making. There's a couple of different options that we have here. First of all, the anomaly detector. The anomaly detector allows me to check what is happening in my environment and detect variations on this. Like maybe I am running a web shop and I want to see, okay, how many orders am I getting in? And then have notification when there's too many or too few orders. And you can just do this, like we'll just look at the stream and tell you whenever something is not as it should be. We also have the content moderator. So here we can actually decide on, okay, if you upload a picture, for example, is this picture something that needs to be moderated? Maybe something that has some things I don't want to see in there, violence or something else. And it will make decisions on what is being uploaded and make sure that you are not showing anything that you don't want to show. And finally, the personalizer. allows you to do that thing. Like if you go to Amazon, you know this, you pick something and it tells you, okay, if you pick this, you might also be interested in this. That's what the personalizer does. It makes sure it creates a rich personalized experience for every user, depending on what they are doing and what they are choosing. And all of this you can bring into your own application. For language understanding, we also have these different options. First of all, we have the immersive reader. This helps reader with maybe disabilities or some otherwise why they cannot read the text. We actually help them comprehend this text using audio and visual cues. Language understanding, LUIS, is about giving a text, actually understanding what's happening in this text. So it might be something like, okay, so we are trying to book a ticket, or we are trying to create a new website, or whatever. But it understands, okay, you are trying to do something, it understands your intent, it gets different entities from there, and then you can bring this into your application to actually start doing something with this. The Q&A maker is perfect to get started with AI, by the way. So the Q&A maker allows you to bring in your own knowledge base, and it will, on top of this, it will bring a question and answer overlay. So you can say, okay, I want to know about how do I reset my PC, for example. It will look up your knowledge base, it will get the text that is about this kind of thing, and it will bring it back to your users. Text analytics is about, okay, I provide a big text and to understand, okay, what is the sentiment of this text? What are the key phrases? Which entities are in there? And we'll just try to understand this big text and actually bring you back, okay, like, I think this text is about X. And finally, the translator helps you to detect and translate in more than 16 languages, where you can go from one language to another language and back again. The speech API, of course, is about speech. So we have speech to text, me saying something and this being translated into text. Or the other way around, me typing something and this being spoken to me. What's even more interesting is speech translation. I can actually talk to this system and to, on the fly, translate what I'm saying. And you might know this, for example, from Skype or from PowerPoint, but it actually translate the text you are saying as you are speaking, and does this near real time. And finally, in this API, we have speaker recognition, which actually allows you to identify and verify who is speaking. So you can actually check, is this person that's speaking, is this actually the person that I'm expecting to speak? So vision is about everything we can see. So for example, we have computer vision, which allows us to analyze content in images. So we can upload an image and we'll understand, okay, what's in this image and maybe do some things around that. Like identifying this might be the Eiffel Tower, for example, or identifying a person in this. Custom vision actually allows you to do this all on your own. Custom vision actually allows you to build your own model, bring in all your own content, actually create a model around this. Actually just say, okay, I want to know if this, for example, is a banana or apple, for example, just to say something. You can just bring a lot of pictures saying, okay, this is X, this is Y, this is C. And from then on, it will actually learn about this and give you the opportunity to build your own model around this. The face API is about recognizing faces. Who is this person? Do I know this person? Is this person in my database? And if yes, what is the ID of this person? The form recognizer, as the name says, allows you to scan text on forms. So for example, maybe receipts. I might upload the receipt and it can get out like the cost in there and the date. And it might bring this into my expense income application. So this actually helps you to extract text, extract key value pairs from these documents. The ink recognizer is about recognizing your handwriting, common shapes. So I can actually write the text in my own handwriting and to understand this. But I could also, for example, draw a house and it understands I'm trying to draw a house. So it understands different shapes, different handwriting, and you can just do this all in your own application. And finally, for this one, the video indexer. So the video indexer analyzes visual and audio channels of videos and then indexes the content and tells you, okay, at this point, this person was speaking, or at this point, there was some movement. So it actually analyzes your video and tells you what's happening inside of this. And finally, web search. And I'm not going to go to all of these because everyone knows search. We have all used Bing at some point where you can do things like image search, news search, spell check. But what's nice about this API is you can actually do this from within your own solutions. So your own applications, your own solutions can actually use all these different types of search and actually bring that context into your own application. So why do we use Azure Cognitive Search for this? First of all, it's very easy to use. You can just roll your own REST API. You can call out to the REST API directly. You might use a connector for this. But it's really easy and very powerful to just say, okay, I want, for example, recognize a face. I just upload the picture to this, call this API with my picture URL, and will bring back like, okay, this is this person. So it's really easy to get started with, without me having to know about all this AI and ML and stuff like that. All this is being done for me and just offered as a service. It's very flexible. Because these are REST APIs, you can actually integrate this into any service, into any language, no matter where you are, you can always use this. And this has been tried and tested. Like this is what Microsoft itself is running their services on. They are running this daily. Whenever you use Word, whenever you use PowerPoint, whenever you use Bing, these are the servers that you are using. So Microsoft is actually trying this out all day, every day, to make sure these services are working, they are working correctly, and you can use them for your own advantage. So not quite cognitive services, but still something that's closely related is bots. So bots are about saying, okay, I want to do something, telling this to a bot, the bot responding back to you, say, okay, so I think you're trying to do this, I will take an action for you. And we have different options when we are creating bots. For example, we could use PVA, Power Virtual Agents. And Power Virtual Agents allow us to create a bot with just doing drag and drop. So it will give you all the dialogues, it will give you the flow, and you just drag and drop, like saying, okay, first I want to ask this question, then ask this question, then maybe you do a decision, like if you said A, then I'm going to do this, if you said B, then I'm going to do that. And it will just create everything for you around dialogues and things like that. So this is very low code, very easy to get started with, but also, of course, meaning that you have a little bit less of control. If you want some more control, but still work low code, there's AdBot as well. AdBot allows you to use these services for either Power Automate or Logic Apps. Actually create your own flow, but also calling out to different systems. So you have a bit more control here. And finally, if you want to have full control, you can use Azure Bot Service, where you can actually program your own bot. You are fully in control how your dialogues look like, how your flow works. You can call out to different applications, to different REST APIs. And this basically means that you can create your own complete bot according to how you want this. So Azure Bot Service is the one we are looking at today. And so the Azure Bot Service actually allows you to create powerful, extendable bots. They are enterprise ready. You can create your own bot. You can completely customize this and make sure that you have the bot that you want. It has some nice integration with Azure Cognitive Services. For example, Lewis, language understanding, is built in. So it actually allows me to say, okay, my bot actually responds to different types of text. For example, if I want to create a ticket, I might say, create a ticket for me. Or I might say, can you please create a ticket for me? Or I want to create a ticket. And all these different sentences, the bot will understand that I'm trying to create a ticket. So it understands my intent. It might get some information out of there, like what's the subject, what are you trying to do? but it actually understands the different sentences and gets my intent on this. And it's very easy to do this into multiple channels. I can integrate this, for example, within Teams, within Skype, within Slack, or within my own website. So enough theory. Let's go to demos, because cognitive services are best explained through demos. And so the scenario I'm running today will be about my personal experience as a worker. So next to my normal daily job, I have another side job. On the side job, I go to these different terminals, because on my side job, basically what I do, I go to ships and I bring them printers, I bring them PCs, stuff like that. But these ships basically always are at these different terminals that you see here in the background. So BP, Esso, Shell, you name it. And so my scenario is about, okay, if I go to these ships, I have to go to the terminal and they have to know, who are you? Because you cannot just go to the terminal, like Shell, for example. You cannot just go say, hi, I'm here to go onto your terminal. No, they have to know, who are you? So they have to know, okay, this person is actually here to come for this ship. So this is me working on these ships. I have to be like this, like you have to wear the hard helmet, you have to wear your jacket. I'm driving there with my car. And so when I go to the ships, the ship has to tell them, okay, this person is coming to work with us. Like he's going to replace our printer, for example. They have to tell Shell, for example, in this case, like this person is coming. He's coming at this time or at this day. He's coming to do this type of work. And what normally happens now is, okay, so I call the ship calls me saying, okay, we need a new printer. At some point I have a new printer. I call them like, okay, when are you at this certain place? When can I come by? They would then call out to the terminal. The terminal would say, okay, what is his name? What is this person? And there's a lot of communication going around with phone calls, emails, just a lot of information that has to be transferred around. So what I'm thinking is, how can we make this better? How can we make this easier? So first of all, the registration part. So when I have to go to a ship, the ship actually has to register me. Like they have to tell the tank terminal, they have to tell, okay, we have something coming on our ship. Can you please register them? And when he comes by, you know that he's coming for us. So this might be through emails. What we are going to do today is actually build a chatbot for this. I'm going to build a chatbot, and this chatbot will basically allow me to say, okay, I want to visit the ship. We'll then check, okay, is the ship registered with us? Do we know this person? Are they actually allowed to come onto the terminal? So let's have a look at that. So over here, I have my chatbot. And as you can see, this chatbot is with the Rotterdam tank terminal. And what I can now do, like as a ship, I could say, okay, this might be integrated maybe into the website of this terminal. It might be integrated into Teams or something like that. But basically what the ship now can do is say, okay, we need to bring someone on board. So what they are going to do is say, okay, they want now to register a repairer. So they tell, okay, I want to register a repairer. This starts the flow, okay. Now the bot understands, okay, so you want to register someone. First of all, which ship are we going to visit? So let's do the Somtons LNG that we just saw in the picture. So what's the name of the visitor? So that would be me. When would this visit take place? Well, let's say tomorrow. What is the reason? Let's repair their computer. My email address, because they of course have to reach out to me saying, okay, you were registered, you can come at this point. And finally, it asks me, okay, I have all the information now. Can you please verify that this is correct? So I will say yes. Now it's going to start my registration. It's going to check, okay, the Somtons LNG, do I actually know this ship? This person has been here before. And now I can say, okay, do I want to upload a picture? Because at some point I'm actually going to the terminal. I want to make sure that I can enter the terminal. So let's upload my picture over here. So I will upload this picture over here. And this picture will actually allow me to say, okay, when this person comes to the terminal, please recognize this person. More on that in a bit. So I've now registered myself. It tells me, please bring your protective equipment. And it asks me, can I do anything else for you? In this case, we are done with the bot. So let's have a bit of a look on the behind the scenes. So I'm using the bot framework here. As you can see, this bot framework basically allows me to create some different intents. As you can see over here, it's actually using Lewis. So it's got this Lewis recognizer. And the Lewis recognizer allows me to have these different sentences. So in this case, I said I want to register a repairer. I might have said, can we please register a repairer? I want to make sure that the repairer can come on board. Like I can use different sentences and it would understand I'm trying to register someone. So if you have a look at Lewis, over here. So if you have a look at Lewis, what we see over here is inside of Lewis, so language understanding service, I have this intent called register visitor. If I look at this, I have these different sentences that I taught it, like I bring in sentences. And this might be, I need to do repairs, I would like to register this person, I would like to come and visit the ship, like, and as you can see over here, so there's an intent, I would like to register someone. There's also some entities in here. Like if I would say I want to register Albert Groteboer, it understands that this is my person name. So if I would actually have said this, it would not have asked the question for this person anymore. Because it already has this person name. Like it understands, okay, this is the entity person. And as you can see, I have different sentences over here, but none of them are actually the sentence I just put in there. They are close, like they are similar, but because this is using AI, I can actually put in some sentences, train the model, and it will understand similar sentences by itself. And will understand whenever I say this kind of sentence, I want to register someone. So what's more, as you can see over here, there's some different different dialogues. So I have the register visitor dialog and the visitor picture dialog, and those are the different dialogues that we just saw. Like one is for the registration, the other is for uploading the picture. So if you look at the register visitor dialog, and I'm not going too deep into this because this is not a bot session, but I just want to show quickly what this looks like. Is you can have different things, like you can have text prompts, attachment prompts, I can have confirmation prompts. So I'm pretty okay with saying, okay, I might just want to say some text, like I want to ask a question. But at some point you also so like, this is the information you provided, is this okay? This was confirmation prompt. I might have a date prompt, like saying, okay, I want to pick a date from this. I could actually go all out on this, create custom prompts and custom experiences for this. For this example, I use pretty low level, like just saying, okay, this is my question, not a question, at some point doing this confirmation. As you can see, I have these different steps. And whenever I come to this bot, it will just follow these steps. And these steps are things like, okay, which ship are we visiting? What is the name of the visitor? What is the date that he's coming to visit? And this actually has this date resolver dialog. So I could say tomorrow, and to actually understand, like tomorrow, okay, so that's date X. And so it does all these steps, and at some point it calls out to say, okay, I've got all your information. It allows me to ask me to confirm this. And then at some point it will actually say, okay, I've got everything over here. I'm going to call out to another API. So what it does at this point is actually call out to another API. And from this bot framework, sorry, not this one, but this one, it actually calls out to a logic app. So I've exposed the logic app, and in this logic app, what I do is say whenever HTTP request is received, so this is just a bot calling out to my logic app, it starts to get some information. So I filled out all the information, like the ship, my name, my email address. And once it has all this information, it will send it out to this logic app. And the first thing this logic app does is actually check, okay, is this ship actually registered with us? So it goes out to Dataverse, and in Dataverse it actually goes and checks, okay, the Somtrans LNG, is this ship actually registered with us? Like, do we know this ship? Is the ship actually coming to us? Is it coming on the date that you set? So it actually goes out and checks all this information. So it gets the ship, it checks if the ship was found. If not, it would just have responded back to the bot saying, oh, I'm sorry, but this ship is not registered with us. You cannot visit. In this case, of course, the ship was found because I already registered this. Then it gets the visitor, like it sent, okay, so Albert Groteboer, do we already know this person? If not, it would actually have gone out for a validation, like it would have told me, like we are going to validate this. It would have sent an approval email to the ship, like saying, okay, do you know this person? Are they coming by for this reason on this date? And then the ship could say yes or no. If they say yes, it will actually register this person, like it will create a visitor. If they responded no, then it would terminate and say, okay, we don't know this person, you are not coming. In this case, I of course already had myself in there. So in this case, it would just say, okay, thank you for your registration. We are now going to update the visitor. It would update the visitor, say, okay, the visitor is coming on this day for this reason, for this ship, and would then create an event. So let me just show you the event that has been created. So actually what it did is go to the ship, go to the person visiting, and in the tank terminal itself, in their agenda, it created this event saying, okay, at this date, this person is coming for this ship. And this is why I love logic apps, by the way. Like there's no code here, basically. I just configure stuff, and I can just, like, for example, create an event, like in Outlook. It's very easy. I just say, do the create event action. I provide my information, and it just works. And there's many different actions in here. So if I go to the All tab, as you will see, there's about 300 different connectors in here. Of course, there's a lot of Azure stuff, Microsoft stuff, but there's also stuff that's actually not Microsoft. So for example, if I go over here, there's Google Calendar, there's Google Drive, there is Huddle. Like these are not Microsoft services. So it's very easy to integrate with all of these services. I just can select something and I can say, okay, these are the fields I want to fill out without me having to know how to connect to Google Drive, for example. I just say, okay, here's my information, here's my credentials, please set up a connection for me, give me the fields I need to fill out, and I can just do this. So at this point, I'm registered. They know I'm coming. They know that I'm this person that's coming for this ship. So I would now say, okay, tomorrow I would step into my car. I would drive up to the tank terminal. And up till now, I would actually have to go, like, okay, I would have to go into this little office over here to say, okay, I'm this person. I'm coming from this ship. Here's my driver's license. Here are the papers for my car. All this kind of information. Wouldn't it be much easier if I could just drive up to the gate, look at the camera, and would actually know, like, hey, you are Eld Groteboer because you already got registered. We have your information on file. We have your picture on file. We just recognize you. And we know you have been registered because we can just look up live in the system, check, hey, are you registered today? Do we expect you actually to come in? And if so, we can just open the gate for you. So let's have a look how we could implement this. So what I would do here is, of course, normally I would have a camera that would take a picture, it would upload this. I'm going to upload it manually because this is not an IoT talk, this is a cognitive service talk. But normally the camera would upload this picture over here. So over here, my demo 2. And this is just a picture, like you can see, it's a different picture than the one I used actually to register myself. I can just upload this picture. It's now uploaded, and what will happen now? This will actually trigger another logic app. So if I go over here, I have this logic app that just started. And what I'm doing, like whenever a picture is uploaded, I get a trigger using Event Grid. And Event Grid just allows me to trigger on different kind of things, like blob created, service bus message created, new resource created. There's a lot of different things that you can trigger on. And then with Event Grid, you can trigger a function or a logic app or another application. In this case, I'm triggering a logic app whenever a file was uploaded. I get a file name, I get a path, like the URL with the SES token. And at that point, I'm going to call out to the Face API. As you can see, this is the Face API. I use the built-in connector. So I don't have to know about how to call this API. I can just use this connector. I give the URL to this image. So this is the image that we just uploaded with the SCS token behind it. But this is the picture we just uploaded. And that's all I have to do to, okay, is there a face in this? So it brings back, okay, there was a face found. This is the face. This is the information about this face, like the nose, pupils, eyes, stuff like that. But for me, the most important thing is just, okay, I found this face over here, and here you can find this. Then the next step I'm going to do is call another operation in this API to identify this face. So I'm going to say, okay, I have this face ID over here. Please check if you recognize this face from your database. And of course, when we registered, I uploaded my picture. At this point, this picture was actually added to a database saying, okay, this is Eldert Groteboer. So if you get another picture, please check if this is Eldert Groteboer from this previous picture. And this is my first cognitive service that actually allowed me to just say, okay, here's a picture. Please check if you recognize this person. So what I did, it actually said, okay, I've got this face ID. And I actually found a person with this, like it's 0.54, so about just over 50% sure that actually this is this person. And this person, of course, is the person I just created when I uploaded my picture during registration. Say, okay, this is Eldert Groteboer. And so this is pretty sure, like Eldert Groteboer, I'm pretty sure that the picture I just saw is also Eldert Groteboer. So in this case, because I got identified, I can now get my visitor details. Once again, we go out to Dataverse. In Dataverse, I have information about me as a person, like I know, okay, I have these visits over here. I've got my name, I've got my email address, stuff like that. So because it actually got back this face ID, or the person ID, it can now look this person ID up in my Dataverse and come back say, okay, this is Eldert Groteboer, and here's the information we have about him. If I would not have identified myself, it would not have done anything, but in this case, I did get the visitor details, and it sent out a message to Service Bus. So let's have a look over here, because actually what I'm doing over here, I have this application, and this is the application that that person in that booth would be looking at. Like he would say, hey, someone is driving up, and I'm looking to the camera, and this would be what showed up for them. Say, okay, so this is Eldert Groteboer. We actually have a registration for him, like on the 16th. Yes, we have a registration. We do expect him. He has done a safety course, so he can now just drive into the terminal. Because we know this is the person, he has been registered, we know why he is here, he has done a security course, so everything is okay for him to just continue. So at this point, I've been registered, I can actually arrive at the gate and they will actually recognize me. But there's one more thing I need to do when I'm at the gate. Because I actually have to do some checks on my vehicle. So every terminal, when you go to the terminal, they will want to do some checks. They will want to know, is your car actually checked for technical status? So we have our yearly technical status update, where you go and someone will actually check your car, say, see, okay, do you have anything that is leaking or anything that's not working? So this is a yearly thing, and they just give you like, okay, your technical status is okay. So the terminal wants to know, okay, this car that's driving up has actually done this check. Also, they want to know what fuel you are using. So for some terminals, you cannot go there with diesel cars. Other terminals, you cannot go there with petrol cars. Other terminals, you cannot go with electric cars. Like they want to know, okay, what type of vehicle are you driving, and are you actually allowed on our plant? So let's have a look how we can do this vehicle check. Not this one. This one. So we have another camera. So I have one camera for my face, another camera that will just scan my license plate. So let's upload another picture. And this is just a picture of my license plate that I'm going to upload. And so then going to do the checks, like as you can see here. Let me just open this. As you can see, this is just my car with the license plate in there. So I want to know, okay, is this car checked and stuff like that. So I'll upload this. And this will trigger another logic app. There we go. And this other logic app, once again, it does the same kind of ID, like it triggers whenever a new picture is uploaded. It gets the file name, it gets SCS URL. But now we are going to call out a different service. In this case, we are going to call out to the OCR service. So actually what this does is I put in a picture and it gets all the text that it gets back. Like it got this strange text, which is not what I'm looking for, but it also got this text, my license plate number. So what I do next, I call out to a function, and all this function does is basically tell, okay, look for a license plate number. Like look for something that has 8 characters, has 2 dashes in it, and looks like just numbers and letters. It then strips out those dashes, and it gets back my license plate without the dashes. That's basically what it does. As you can see, I get back my license plate number. At this point, I can get my information for my car, because I now have my license plate number, so I can now get my car information. And what I do for this, I call out to API management. So let's go to API management over here. And in API management, I've got this RDW. And RDW is our local service that has all the information about all the cars in the Netherlands, where you can just get information about this. So it's just an open endpoint. So anyone can call out to this. It's an open data endpoint. And basically what I do, I have 2 different ones. But for example, for licensed cars, I have this license endpoint. I provide my license plate number and then just calls out to this. So what I do here, I provide my license plate number and it gets back the information about, okay, so this vehicle is a Volkswagen Golf and the one I'm looking for is this one. So the APK, as we call it, that's the yearly checkup. And this tells me, okay, so this car has an okay checkup till 2021, month 7. So it knows, okay, this car has already been checked in the last year and it is okay. Same for the view information, so just a different API of the RDW. But basically, I pass in my license plate number and brings back, okay, this is a benzine, which is petrol car. But benzine, of course, is Dutch. I don't want to do this in Dutch. I want to do this in English. So I actually have to do a translation on this. So this is not a cognitive service. So we actually are using the translator service for this. So once again, in API management, I've got this translator service. And this is just the translator service within my Microsoft Cognitive Services. And what I do here, I pass in my text in Dutch. I tell it, okay, please translate this from English to English from Dutch. And it will come back to me, okay, so benzine is actually petrol. I can now send another message. And once again, this comes over here. As you can see, I now have my license plate number. It knows, okay, this is a petrol car. And tells me, okay, the periodic maintenance has been done. So this gives all this information back, like, okay, this is the car, this is the information. So I can now actually enter the terminal, like they know, okay, this person has been registered, he has been taking his security things, the car is okay, it's a petrol car, they can enter the terminal. I would now just drive on without having to get out of my car, go into the booth and stuff like that. I would just have to look at that camera. They would know, okay, this is Oud Grooteboer. He's coming here for the Somtrans LNG. So I can now drive on. I can do my thing. I can go to the ship. I can do the exchange of the printer or repair this computer. And at some point, I have to actually depart again. So at departure, I have to sign a worksheet. So every refinery you go to, they will ask you to, okay, please fill out this worksheet to know which ship you were on, which date. So actually, you just want to know that you actually went to this ship. So on the ship, they would just sign this, they would fill this out, they would sign it, and then give back to me. And then, of course, when I'm trying to drive out, they would actually check, okay, do you have the right approvals, were you on the right ships, things like that. And so to give you an idea what this looks like, is like this. So like I said, this is just a normal worksheet. I tell, okay, which ship did I visit? Why did I visit this? Who signed this? The signature, the date, stuff like that. And as you can see, this is just my handwriting. My handwriting is not nice. Let me just say that. Like, I actually cannot read my own handwriting sometimes. So what we are going to do is actually check this once again using a cognitive service. So what I'm going to do is over here, is I'm going to upload another picture. So the picture I just showed you, We are going to upload this. It's uploaded. Once again, we are using Logic App for this because I like Logic App because it's quite easy. You could also use a function or something else if you would like that. But in this case, I'm using the Logic App. Once again, I get triggered. I create a file path. I retrieve my latest model because whenever I train this form recognizer API, that's the one we are using now, like the form recognizer. Whenever I train the form recognizer, it will create a new model. So I always want to use the latest. And then I'm doing this analyze with custom form. And once again, it's going out to API management. And I'm calling out to this form recognizer API. Once again, this is a cognitive service. And basically what I did is I trained this model to say, okay, these are the pictures like the ones with the green mark on it. These are the trained pictures. So what I did is say, okay, I've got some different labels. I've got a ship label, a reason label, signee, date, and signature. And then what I did is I can just click on my picture over here and say, okay, so these two fields together, that's the ship name. These together, that's my reason. These together, you get the ID. I did for a couple of different pictures with different text and stuff like that. And then I trained this model. So I uploaded the pictures, I set the labels, I then trained the model. And from then on, it actually understands whenever a new picture is uploaded. So this is one we just uploaded. As you can see, there's no green box there. Basically what it did was, okay, it's going to recognize different text on top of this. And just to show you how you do this training, like it's just like clicking around on this and then say, okay, this might be the ship. It's that easy to do this. So it called out to this form recognizer. It then waited for did a couple of different tries because it takes some time to actually recognize the data. But at some point it said, okay, I'm done now, and I actually got back some text. Let's go to the last one. Let me just do it like this, that's easier. So in the last one, I actually got back my form results and said, hey, it succeeded. And I want to go down here because these are the ones I'm looking for. So I have these fields, and these fields are the labels I determined, like the field, ship, the date, stuff like that. In this case, actually said, okay, date. I found the date over here. I found the signature. I found the ship name. So actually just read that document and got back this information. And then once again, it parses that information and creates another message going out to that operator. In this case, so this is my message, this is my form. As you can see, it recognizes sometimes LUG. So like I said, my writing is not perfect. So it actually doesn't recognize this as an N, but as a U. But still, it's very close. Like sometimes LG, like, okay, the operator would know, okay, that might be sometimes LNG. The reason, like computer repairs. And this is like very hard to read. Like it still got like, okay, computer repairs, it got a date, it got signed, and actually recognized that the signature was found as well. So now I'm at the gate. I just show this in the camera. They don't have to do anything. It will just take the picture, it will process it. And a few seconds later, it will show up with the operator saying, okay, this person actually has been on the ship. He's been on this ship. Everything is okay. We can now open the gate again. And as you can see, it was very easy for me to do this. Like I basically have nothing to do here. Just to show you what I actually had to provide here. And this is for all these different cognitive services. Like it's just so easy to use them. Okay, it's not. Let me just load another one. Okay. So let's go over here. Let me load up. Let's do this one. That's a nice one. So to use these cognitive services, like I said, I can use an out-of-the-box connector. In this case, the only thing I have to provide is my image URL. So very easy to use. I might also say, like, okay, for the identify, I might actually call out directly to this API. Like instead of using a connector for this, I might just say I want to call out to the API directly for some reason. Maybe because there is not a connector there, or maybe because I'm doing this for my application or something else. But even then, like it's like 5 fields that I have to give. I have the face ID I just got back. I have the maximum number of candidates. I have the person group ID. So it's very easy to just call out to this endpoint, provide this information, and then it does all the information like whether it's detecting the face, identifying a face, getting that information for my form. All those things are just so easy to use. Like I actually, all I have to do is just say, here's my picture, and please don't do this thing for me. So with that, we are almost done. So I hope you like this so far. So a couple of takeaways I want to give you. First of all, it's very easy to do this complex work because, like I said, I can just call out an API and I can say I want to recognize some information from this form. I don't have to build any logic. I don't have to build any models. I just train my model once, like I upload a few different pictures. I say, okay, these are the fields. And then from then on, I can just upload any form and it will just recognize, okay, this was text. Or I can just upload a picture of my face and will recognize, hey, this person has actually been registered. This is Eld Groteboer. So I don't have to build anything myself. It's just very easy, but you can actually do quite complex work with this. Like if you have ever tried to build a model that recognizes face, you know this is a lot of work. And it's really hard to do this. Thanks to the cognitive services, anyone can use this. Like I don't have to know how to do this. I don't have to know AI or ML or stuff like that. I can just say, I just want to use this and do this for me. So it's actually just doing this stuff as a service. It's extensive. So I showed you the different options in the beginning, like there's like about 20, 30 different APIs already available out there. And this also just keeps expanding. Microsoft is continuously bringing in new services, new applications, new opportunities to use this. So keep an eye out on the Cognitive Services webpage because there's always new stuff coming. And like I said, this is stuff that Microsoft is actually working with in their own applications. Like this is tried and tested. And whenever they have something new, they will share it with you so you can use this in your own solutions. And finally, it's very easy to integrate this into your own process. So you can actually use cognitive services, build this into your own process, and say, okay, I want to now, for example, call out to an API that does the face recognition. Or I want to, here's an audio clip, please translate this for me. You can use this in your own process by just calling out to these APIs. I was using Logic Apps today, but of course you can also do this from any application, from any language. You can do this from functions, from APIs, from your own applications, whatever you want. Just make sure you use the right things for this and use this in your own processes whenever you need this. So with that, I would like to say thank you. Thank you for being here today. I hope you have an amazing day today with all the other sessions. If you want to reach out to me, like I said, you can always contact me on Twitter. You can send me an email if you have something more to say. We can connect on LinkedIn. So thank you so much. I hope you enjoyed the session. I know I did. Thank you for having me here today. And once more, thank you to Microsoft for actually sponsoring this stuff because we need this kind of opportunities to actually share our knowledge, to gain new knowledge, especially in these troubling times. Knowledge is more important than ever because we just want to continuously improve ourselves. So once again, thank you so much and enjoy the rest of your day.
Hi all, welcome to the session Cardinality Estimator 2014-2019. My name is Dan Samovic and I will try to explain you the differences between Cardinality Estimator and SQL Server from version SQL Server 7.0 to SQL Server 2014, because on SQL Server 2014 there was a big change, and the first change since SQL Server 7.0. So let's start. First of all, thanks to our partners, to Microsoft for sponsoring this event. So thanks to sponsors. A little bit about me, not too much, because you're here for the session, not for.
Sorry, Dion, I cannot see your presentation to share it.
Sorry?
I cannot see the presentation to share it to be able to view.
Oh, I have to share it. I thought you shared that for me. Sorry about that. Can you see it now?
Yes. Okay, that's
Sorry
great.
about that. Okay, should I go from the top? Okay.
Now I can go.
Okay. So, hi again. Welcome to the Cardinality Estimator session 2014-2019. First of all, thanks to the partners, to the Microsoft, to the sponsors. Big thanks to the organizers. And a little bit about me. My name is, as I already said, Dejan Savovic. I'm the co-organizer of SQL Server User Group Croatia. I'm also co-organizer of previously called SQL Saturday, but now it's called Data Saturday Croatia, that will be held in September 11th, 2021. I'm Microsoft certified trainer, and if you want, you can reach out to me on Twitter, LinkedIn, and via email. Today's agenda is it's all about Cardinality Estimator in SQL Server. So as I said previously, there was a big change in Cardinality Estimator in SQL Server version 2014. And there were some improvements in 2016, 2017, and 2019. We will talk about all of them. But before that, we will do a little intro on Cardinality Estimator. We will talk about model assumptions, calculation direction, and model versions. And at the end, we will talk about troubleshooting, how you can troubleshoot Cardinality Estimator and your SQL Server queries and stored procedures. And we will have, of course, a conclusion and Q&A. So let's start. So what is a Cardinality Estimator? This is a part of SQL Server Query Optimizer, which is responsible for building execution plans. I presume you all know what is an execution plan of a query, so I will not talk about that. For SQL Server to build an execution plan, he needs to have cardinality estimates of the operators in the plan. Cardinality estimate is one of the attributes that SQL Server Query Optimizer uses to build a cost for the execution plan. And you all know that choosing an execution plan is cost-based in SQL Server. So this is very important part of the Query Optimizer. What does Cardinality Estimator do? So as you can see on the slide, it decides on how many rows will satisfy a single filter predicate. And of course, if you have multiple filter predicates, Cardinality Estimator also does that. So it estimates how many rows will satisfy a single or multiple filter predicates. Then how many rows will satisfy a joint predicate between two tables. This is also very important to know for Query Optimizer. And if you have a group by or distinct, how many distinct values do we expect from a specific column or a set of columns? So Cardinality Estimator, of course, as the name tells us estimates number of rows. So what happens if estimator underestimates rows or overestimates rows? These are both not good conditions for query optimizer, because when the rows are underestimated, then SQL goes into a serial plan when parallelism would have been more optimal. He chooses inappropriate join strategies like nested loops over hash match, and the query runs slower than it should. And it chooses wrong indexes and wrong index navigation strategies. For example, seek over scan, and this also makes our queries run slower. If we ran into an overestimation problem, then SQL goes into a parallel execution plan where it should have gone into a serial plan. So it uses more CPU power to execute the query. Again, we have inappropriate join strategy selection. In this case, hash match over nested loop. And wrong navigation strategies for indexes. It uses scans where he should have used seeks. We have inflated memory grants, so SQL uses more memory than it should. And this leads into a wasted memory problem and lower concurrency possibility on SQL Server. So these are all problems that we can run into when cardinality estimator is wrong. Next, we will talk about cardinality estimator model assumptions. Those are independence, uniformity, containment, and inclusion. Independence means that data distributions on different columns are independent unless correlation information is available, like statistics or like statistics, period. And the next one is uniformity. So this means that within each statistic object histogram step, distinct values are evenly spread, and each value has the same frequency, which is most of the time not the case in real world databases. So we have to deal with that. And the containment and inclusion are pretty similar. Containment is if something is being searched for, then we presume that this actually exists. So if a user is searching for, I don't know, city of Zagreb in a database, then or Sofia, then SQL Server presumes that record actually exists. And inclusion means that for filter predicates involving a column equal constant expression, the constant is assumed to actually exist for the associated column. So SQL assumes that users are searching for something that exists in the SQL Server. Okay, calculation direction is from right to left. So query optimizer and cardinality estimator works his way from right to left in the execution plan. This is an example of a simple execution plan. So first, the rightmost operators are calculated, then SQL and query optimizer goes to the left and calculates the cardinalities of those operators from right to left. As I already said, the biggest change in the cardinality estimator of the query optimizer part of the SQL Server was made in SQL Server 2014. And the cardinality estimation model version is 120 for that SQL Server version. And how can we influence the cardinality estimator model version, or can we influence the model version at all? Yes, we can. And the ways that we can do that is on the database level and on the query level. We can use compatibility level of the database to influence the cardinality estimation model version. If we use compatibility level of 120 or above, then the cardinality estimation model version will be 120. And if we use 110 for compatibility level, which means SQL Server 2012, we will limit the SQL to use the cardinality estimator of SQL Server 7.0 or 70. We can do that with trace flags also. So we can do it on the query level. So the trace flag 9481 means that we want to use legacy cardinality estimator, and 2312 means that we want to use new cardinality estimator. So this gives us the flexibility, these trace flags and query hints, to have the database in particular cardinality estimator model version by setting the database compatibility level, and then with query hints or trace flags force the particular query to go into a different cardinality estimator model version. For example, when you migrate the database from 2012 to 2014, you see some regression problems, and most of the queries of your database are regressed. You would then obviously choose to decrease the database compatibility level to 110 to the old version. And then for the queries that are running good on new cardinality estimator, you would use a query hint to force the new cardinality estimator model version, or use the trace flag, session level trace flag, to force the new cardinality estimator. Enough about that. I hope this is clear. Now we will talk about the main thing about this presentation. These are the improvements in SQL Server 2014. So the first one is increased correlation assumption for multiple predicates. So in old cardinality estimators, 7.0, data contained across different columns as uncorrelated with one another. So SQL Server assumes that data across different columns is uncorrelated with one another. And the new cardinality estimator assumes that there is some correlation between data, and it uses exponential backoff to calculate the cardinality of those queries. We will see all this in demo, so I will just now talk about these improvements, and next thing will be a demo. So in demo, I hope that things will be more clear. The next one is the old problem we had for a long time. This is a modified ascending key and out of range value estimation. The thing that happens when you have a statistic on some column, and statistics, as you all know, can only have 200 steps in the statistic histogram. And because of that, it can happen that users are searching for the values that are out of range of the histogram. We will also see that in the demo. And in this case, the old cardinality estimator estimates a fixed value of one row. And on the other hand, the new estimator assumes the data exists, as this was one of the assumptions we talked about earlier. And the cardinality is calculated as table cardinality times density. This is the formula that SQL Server Query Optimizer and Cardinality Estimator uses. The next improvement is about distinct and group by. So distinct value count estimation changes. And if you in your query have a many-to-many join operation, then the difference between all the new cardinality estimators is big, huge, in favor of new cardinality estimator. And if you don't have many-to-many join operations, then the difference between the estimation is very small. Then we have join estimate algorithm changes. For example, we have simple join conditions, when we join two tables on one column, for example. And in this case, a new estimator uses a simpler join algorithm using minimum and maximum histogram boundaries. And that way he gets better estimates than the old estimator. Then we have queries with multiple join conditions. So multiple columns involved in the joins. And the new cardinality estimator estimates join cardinality based on multi-column frequencies computed on join columns. Then we have joins with equality and inequality in predicates. So greater than, less than, and equals. When we combine that, we will see that in the demo. New cardinality estimator assumes that there is one-to-many join association between a large table and a small table, and the estimated size of the join cardinality is the size of the larger input in that join. Then we have join containment assumption changes, where a new estimator uses base containment as assumption, and filter predicates on different tables are not correlated. Before we go to improvements on SQL Server 2016, let me switch to my management studio and show you the first demo. In this demo, we will be using AdventureWorks 2012, but we will put it in compatibility level of 120, meaning that this database will behave like it's on SQL Server 2014. So let's do that. Let me increase the zoom. I hope you can see the code. And let's now, we have a statistic and index on table person address involving person address and involving state province ID, and we will drop that for the sake of the demo. I will now include actual execution plan to see the execution plan. And first query and second query are exactly the same. We are filtering on state province ID, city and postal code with same literals. Okay. But in the first query, I'm forcing with the query hint with the trace flag 9481. I'm forcing SQL Server to use the cardinality estimator 70. And in the second query, I'm not doing that, so we will use the cardinality estimator 120. So let's select all this and execute. Okay, so we get the same count of rows, 194 for the second query, because the queries are the same, and the execution plan is the same, but there is a difference in the cardinality estimates. Let me hover over, okay, and zoom in. So we have an estimate of 1 in the cardinality estimator 7.0, and the actual number of rows is 194. I'm sorry about that, my kid left the phone in the room. And in the second query, which is on cardinality estimator 120, I will show you now the estimate. The estimate is 13.5. and the actual is the same, 194. Okay, so the new cardinality estimator is a little bit better. Now let's go further. And I would like to show you one other thing, and that is how to determine which cardinality estimator are you using. Just click on the leftmost operator of the query execution plan, and you will see here the cardinality estimation model version is 7.0. Okay, and here is 120. Okay, this is how you can determine the cardinality estimator model version you're using. Let's now create the statistics on postal code, city, and state province ID. These are the columns you are using in the filter predicate, and see what happens. So we have the same queries again. Okay, let's see the execution plan. Execution plan says that estimated number of rows for 7.0 is 6.8. So it's increasing, but still not close to 194. And for new cardinality estimator, it is 13.5, and actual is still 194, of course, because the query is the same. So this is 2 times better than the old cardinality estimator, but not even close to the actual number of rows. Let's now drop the statistic we just created, and we will create the index with the same columns. So the statistic will be created automatically, and see what happens. The estimates, as you all know, will be the same because we have the same execution. We have the same statistic on the columns, but the execution plan is now different. Let's see the estimates, 6.8. Okay. And 13.5, so the same as in the previous query. But now we have index sick because we have an index. So previously we had only the statistics, multi-column statistic, which SQL Server cannot create on its own automatically. But now we have statistic and then supporting index, and now we can use, SQL Server can use index sick. Let's go to the second example. A second example is ascending key example, for which we said that SQL Server 7.0 estimates a fixed number of 1, and the new cardinality estimator assumes that there is some data in the table. First, we will create automatic. We don't have a statistic on the order date column on sales order header, so I will execute this query to force SQL Server to automatically create the statistic on order date. Okay, let's see what is the name of that statistic with this query. This is a query from systats and systats columns. I'm searching for all statistics on the sales order header table on the column order date. Okay, so this is the name of the statistic. And let's now see the histogram of this statistic with dbcc show statistics. Okay, here is the statistic header. Here is the density vector. And here is the histogram. We can see that the lowest boundary of the histogram is July 1st, 2005, and the highest boundary is July 31st, 2008. So now I will insert some rows for July 1st, 2021 in the order date column, and I will insert 50 records. 50 records is not enough to auto-update the statistic. And next, we will query the table for exactly that date, July 1st, 2021. And let's see what happens. I will include actual execution plan. I forgot to do that. Okay, so I have execution plans. And for 7.0, I have an estimate of, as we said in the theoretical part of the presentation, 1. And actual is 50 because I entered 50 records. And here for the new cardinality estimator, we have an estimate of almost 28. And of course, the actual is 50 again, because it is the same query. So new cardinality estimator assumes that there is some data, and it is better in the estimate. Let's just clean up. Okay. The next demo is about simple joins. So we will use AdventureWorks DW 2012. I will put it in compatibility level 120, so we can use the new cardinality estimator. Let's go into this database, and we have again 2 queries which are completely the same. We are joining between fact reseller sales and fact currency rate on the currency key column. First is for 7.0, and the second query is for the 120. And let's execute these 2 queries. Include the actual execution plan and execute. And now for the first query, we have a merge join operator that joins these 2 tables. And the estimated number of rows per execution is 14264. We can see this here. And the actual number of rows is 5790, so 5790 rows. So the old cardinality estimator overestimated by 3 times the number of rows and used merge join for the join operator. And the new estimator estimated 5010, and actual is of course the same because it is the same query, so it is much closer to the actual number of rows and better than the old cardinality estimator. Next demo is about multiple join conditions. We will again use DW 2012. We will, on fact product inventory, drop a primary key, because primary key, we will see that in the end of the demo, influences the cardinality estimator. Make a better estimation. And we have joined between fact internet sales and fact product inventory on product key and date key. So let's see what happens now. I forgot to include the actual execution plan. Okay, in the actual execution plan, we have almost or exactly the same plans for both queries, but hash match for the old cardinality estimator estimates 51,560 rows, and the actual is 60,000, so it underestimates. And the new cardinality estimator estimates 98,000 rows. Sorry, this. So it overestimates. So which one is better? It is hard to say. You have to test for your load and see which estimator is better for your load. The good thing is that you can influence which cardinality estimator you will use for those kinds of joins. Now let's put back the primary key on fact product inventory we dropped in the first step. And now let's see how this influences the cardinality estimator. So we are running the same queries again. And now we have a different plan. And the estimation is spot on. 60,398, 60,398. So exactly as the actual number of rows. And for the new cardinality estimator, it is the same. So if you have primary key, when you have multiple join conditions, then it helps SQL Server to make a better estimation. Okay, are there any questions? Maybe I forgot to tell you, you can put questions in chat. No questions? Okay, let's move on. Next demo is joins with equality and inequality predicates. So what does that mean? We will again use AdventureWorks DW 2012. We will again drop the primary key on fact product inventory. And we will join fact internet sales with fact product inventory with an inner join on product key and date key with the quality operator, and order quantity has to be greater than units balance. So we have an inequality operator. Let's include actual execution plan and run these two queries. Okay, so we have execution plans, and in the execution plan, let's see the estimations. So the actual number of rows is 22,555, and the estimated is 331. So not so good. And the new cardinality estimator overestimates the number of rows and estimates 776,286, and the actual number is way lower than that. So in the first case, you could get a temp table spill to tempdb, and you get lower memory grant, so query could run out of memory. And in the second query, you are using too much memory for the query, and the concurrency is decreased because of this. Which one is better? Well, again, you have to test that on your load and see which cardinality estimator is better for your load. Let's just put this primary key back and go to the next demo. Next demo is join containment assumption changes. Okay, in this demo, we are using the query that joins sales order detail with the production product table on product ID, which is a foreign key, and this is a unique key, primary clustered key on product table. And as an addition, in the predicate clause, we have filtering on product. We are searching for red products. And on sales order detail, we are searching for orders on 31st of May of 2011. First query is again for cardinality estimator 70, and the second is for 120. And now let's see the difference. Okay. So in the first query for cardinality estimator 70, the estimate is 1 and actual is 0. And for the second one, the estimate is 14 and the actual is 0. So the old cardinality estimator made a better estimate in this case. So really you have to test on your load to see which cardinality estimator model version is better for your load. Let's go to the next demo on distinct, or in this case group by, which is practically the same. We are using join between two tables, fact, internet sales, and dim date, and filtering for sales territory key 8, and grouping on product key and day number of year. So we are grouping on columns that are from different tables. Again, running that on old cardinality and new cardinality estimator. And we will do that on AdventureWorks DW 2012. Okay. Let's run this. And I have to include actual execution plan. And in the actual execution plan, on the distinct sort operator, let's see the estimates. So the old estimator made an estimate of 4,500, and actual is 4,700, so not so bad, but it made an underestimation. And the new estimator estimated 5,300, which is an overestimation. So which one is better? It is hard to say. They are both pretty good, I would say. And that's it with demos on SQL 2014. Are there any questions now? No? Okay. Let's go to SQL 2016 improvements. So from SQL Server 2016, we have improvements like compatibility level guarantees. So this means that there will be no planned changes if we stick with an older compatibility level. So if you choose compatibility level of 110, you will have the old cardinality estimator, and there will be no planned changes for you. So if you migrate to the SQL 2016 or above, you can influence the cardinality estimator by simply changing the compatibility level, and you will have no planned changes. Then about statistics, there is an improvement of parallel update of sample statistics and sublinear threshold for update of statistics. And regarding cardinality estimator and query optimizer, which builds the execution plans, there is improvement of batch query processing in serial queries, sort operator which can run in batch mode, window aggregates that can run in batch mode, and distinct aggregates that can also run in batch mode. Let's go to the SQL 2017 improvements. They're all under the marketing name Adaptive Query Processing. And we have 3 of them. First one is interleaved execution. Second one is batch mode memory grant feedback. And the third one, batch mode adaptive joins. Let's go through each of them. What does interleaved execution mean? It means that if you have a multi-statement table valued function and you are using it in your query, then the estimate from that multi-statement table value function will be the actual number of rows that multi-statement table value function is returning. So before 2017, the guess or the estimation for the MSTVFs was 100 rows, and you could have problems if this function returned, for example, thousands or millions of rows. In the 2017 and above, the process is SQL Server runs the optimized process, runs into a multi-statement table value function, executes it, and gets the actual number of rows from that function. Again, goes to the optimized phase of the building the execution plan. He knows the actual number of rows, and at the end executes the queries, and you get good performance. And because the SQL executed the function in the optimization phase of the building the execution plan, when it gets into the final execution of the SQL server query, of the SQL query, he doesn't need to execute it again. So this is beneficial also. I will just briefly go through the batch mode memory grant feedback. It is very simple to explain. This means that when you get a query that gets more memory than it needs, in the second execution it will get less memory, and vice versa. If you get into the loop that the same query is getting more and less memory, SQL Server will stop that based on the testing of Miloš Radivojević. It is around 30 times that that query can go up and down memory-wise, and then it will stop. The next feature of SQL Server 2017 that's very interesting is batch mode adaptive joins. And this means that on runtime, SQL Server will decide if it will use hash join or nested loop join operator, which is a great feature because to some extent it deals with the parameter sniffing problem, but only to some extent, because execution plan that is built has a new operator for joins called adaptive join operator that works only in batch mode operations. So only when you have column store indexes on your tables. And it works like this. It has a cost threshold, adaptive threshold property in itself. And if the number of rows going to the, from the build input is higher than this threshold, then it will use hash join. And if it is lower than the threshold, it will use nested loop. And this all happens in runtime. So you don't have 2 plans, one for hash join, one for nested loop join. You have one plan with adaptive join, which then in runtime chooses which join algorithm it will use, operator will use for joining 2 tables. Improvements in SQL 2019 include, of course, improvements in 2017, adaptive query processing. I will not talk about that again. The marketing name is Intelligent Query Processing, and they include table variable deferred compilation, batch mode on row store, scalar UDF inlining, and approximate query processing, and memory grant feedback in row mode. So on 2017, the memory grant feedback worked only in batch mode, and now on 2019, it works also in raw mode. First, let's go through the table variable deferred compilation. It's a much similar feature like interleaved interleave execution of multi-statement table valued functions, but it works on table variables now. So from SQL 2019, SQL gets the actual row count of the table variable. Before that, it was a one row guess. This doesn't mean that SQL will add column statistics on table variables, and it doesn't increase recompilation frequency. But of course, you are, as with all other cardinalities in the execution plan, prone to parameter sniffing. Because what happens if the first execution of the query goes with the number of rows in a table variable of 10, and then you try to execute the same query with the number of rows in the table variables of 1 million. This is the known issue that you have to deal with. Next feature is scalar UDF inlining in SQL 2019. Before SQL 2019, scalar UDFs were iteratively invoked row by row. Execution plan was lacking costing. It was an interpreted execution, and the execution plan of a query that had scalar UDFs could not be serial. It could not be parallel. It was always serial plan. The new way is that SQL Server transforms UDF into relational expressions using case statements and something like that. It is set oriented and it can run into parallel. So it's not a black box anymore to SQL Server. SQL Server exactly knows what is in the function. It unwraps it and executes it, transforms it into a relational expressions, and it can run into parallel in the execution plan. There are a lot of requirements that you have to satisfy for this to work. I will not go through them. You will get the presentations on you, so you can examine this by your own. And the last feature of SQL 2019 is approximate query processing. That is a new count function called approx count distinct, which you will most probably use when you need responsiveness over precision. As the name of the function says, it is not it is an approximative value that will be returned to you, so you will not get the correct number of rows from the table, the correct count, but it will be faster and it will use less memory. And batch mode and row store on SQL 2019. So batch mode plans work on SQL 2019 with row store indexes. So you don't need any more column store indexes to run queries in batch mode. Scenarios when you would use that is analytical queries on transactional databases, which are CPU bound, and if column store index is too much overhead for your transactional database. SQL Server uses heuristics to choose the batch mode plan, and operators that can go into batch mode on row store are listed here. So they are hash join, hash aggregates, sorts, window aggregates, filters, concatenations, and compute scalars. Limitations are you can only use disk-based tables and indexes, so you cannot use this on in-memory tables. And regarding data types, you cannot use large objects, sparse column sets, and XML. A few words about troubleshooting. Let me see how am I on time. Yes, we have a couple of more minutes. So, when will you have problems regarding cardinality estimators? Most often when you migrate from older version of SQL Server to a new version of SQL Server. And if you are migrating from 2012 to, for example, 2014, 2016, 2017, 2019. Why? I explained why. Because the biggest change was on 2014. And how can you troubleshoot this? Well, the best way, if you are migrating, and I hope you are on 2016 or above, you have the ability to use Query Store. Query Store is a great tool because you can capture queries in Query Store on old compatibility level and then switch to a new compatibility level and see regressions in Query Store. It is very easy to do that in Query Store from Management Studio. So you can get all the queries in one place that have regressed. And you will see then if these are important queries that are running very frequently or not. And then you will decide whether to switch to old compatibility level or stay at the new compatibility level. The next thing I would like to emphasize is multi-statement user-defined table functions, which from SQL Server 2017 are now not at fixed cardinality of 100. And if you relied on that cardinality, now you will have problems on SQL 2017 and 2019. Next, query hints. Use them with caution, of course. You already know that. But very, very useful query hints are those I showed in the demo, which force old or new cardinality estimator. And this is the way to overcome the problems with query plan regressions. This is all I had to say. I think I'm on time. Are there any questions about this topic or about any topic on SQL Server? Okay. Let me just summarize this session. So new cardinality estimator 120 brings improvements. It can also bring problems. As you saw in the demos, you can troubleshoot them and resolve them by using query hints or compatibility level of the database. You have various troubleshooting methods. You should test, and don't forget to use Query Store for plan regression resolvement if you are on SQL 2016 or above. I hope you enjoyed this session, and I want to wish you a great day with the rest of the sessions. Thank you.
Hello. I hope you hear me, everybody. And welcome to Historical Data with SQL Server System Version Temporal Tables. And I'm Damir Matešić. So a little more about me on the next slide. Thank you to Microsoft. And it's important that such a great partner is part of this event, because without sponsors, this event could not be possible, of course. So who am I? For many years, I was a developer, mostly programming in ASP.NET, using C#. I was using also many other technologies. And after all, I oriented myself in SQL Server development and optimization. Last almost 9 years, I'm working for a great company named Span, and my current position is senior database developer. For more than 2 years, I am leading the Croatian SQL Server user group, and from 2019, with some friends, I am organizing SQL Saturday events in Croatia. I'm also co-founder of Data Weekender conference. I'm writing my blog about SQL Server, and in 2019, Microsoft rewarded me with the MVP status for my contribution to the community. I speak on various conferences and events. Agenda of today's session is about system version temporal tables. So what are they? Why do we need them? Some old solutions. What are the prerequisites and limitations of them? How it works generally? How can we query data? And of course, we'll have a nice demo. So let's start. What is the system version temporal table? First of all, it is a confusing name. It is actually a built-in support for handling and archiving old versions of modified data over time. It involves two tables. First, the main temporal table, and second, a history table. The history table has an association. It is an associated table into which the system records all prior versions of each record with their period of validity. The value of each record at any point in time can be determined. So actually, we can tell that we can time travel through the data. Why do we need them? For example, for many reasons. We can use history data for reports. Maybe we want to see some trends over time, to detect some anomalies, maybe to undo data if we've made some mistakes, for example, in an update or delete. We can get the data in some point of time, and also, of course, for auditing. What are the old solutions? There are many of them, based, for example, on some triggers or custom solutions. But what is common with these solutions? They are complex, expensive, limited, inflexible, and inefficient. What are the prerequisites and limitations? There are many of them, of course. Let's start with the main table. So the main table must have a primary key. It must have two columns. The first one, start. It is a system time. And the SQL code is shown on the screen. You must have the end column, is the max date value. period of time. It must have a period for system time defined with two date, two columns. And one hint, of course, if you are changing your existing solution to support this feature, you can hide these start and end columns. So for example, if you are selecting with select star, you will not get in the result set this data. And this is important for some old solutions. Limitations. Data. The table cannot be file table and cannot contain file stream data types. On update, insert, update, and merge statement cannot reference and modify prior columns. Triggers. Instead of trigger are not allowed, of course. Truncate. You cannot truncate a table if it is turned on. Blob data types. The system version tables support blob data types. For example, varchar max, images, etc. But because of performance issues, primarily storage cost, it is better to take care when using these data types. Cascade. On delete cascade and update cascade are not permitted on the current table, but this only is valid for SQL Server 2016. From SQL Server 2017, CTP 2.0, this is also supported. The requisites and limitations about the history table. Constraints. The history table cannot have constraints defined. For example, primary keys, foreign keys, check constraints, table constraints, column constraints, etc. The data cannot be, of course, a file table and cannot contain file stream data type. Modifications. Modifying data in the history table is not allowed. Altering and dropping. You cannot alter or drop the history table. Triggers. No insert of and after triggers are allowed. Objects and properties. Not to the history table when the history table is created. So prior definition, identify definitions, indexes, statistics, check constraints, triggers, partitioning, etc. Schema. Schema is same as the main table, the data types, the columns, and even column ordinal position. Databases. History table must be created in the same database as the current table. It is page compressed by default. Partitions. If current table is partitioned, the history table is created on default file group because partitioning configuration is not replicated automatically from the current table to the history table. And warning. When we make a change to the temporal table, the same changes are applied to the history table. So, take care if you, for example, drop a column in the main table, you will lose this column in the history table, and you will be unable to recreate this data. How it is working. So, a user wants to insert some data, and if we are talking about inserting or bulk inserting, the data are written only in the temporal table. Okay, in the case of update, or for example, delete of data, the system make changes also to the history table. So, deleted records are visible only in the history table and not more visible in the temporal table or the main table, of course. If you update the records, a copy of the data will be visible in the history table, all the data, of course, and the actual row will be visible only in the temporal table. So, how it works when retrieving data? So, if the user write select star from a table. Then the result will be selected only from the temporal table, all the main table, of course, because the user don't actually need to know that there is a history table. But if you are using temporal queries, and these are special queries for retrieving temporal data, for example, history, point in time, etc., then the system will retrieve also the data from the history table. Are there maybe some questions until now? Seems like not. Okay. How can we query data from a system version temporal table? First of all, select star from table. In this case, the result will be all the data from the temporal or main table. The user will, of course, not know that there is a history table and will not get the old data. So the user will get only the actual rows. Secondly, with this syntax, select star from a table for system time all. We will get as a result all the data from the history and the temporal table. This type of select is completely the same as, for example, if you are using select star from the main table, union all select star from the history table. Third way of retrieving data, as of date time. So the syntax is shown on the screen. Select star from the table for system time as of and a date time. So actually the system will make the join by itself and it will return the state of the record in the exact time that is specified here. For example, if you have a table with a number with population of a country in, for example, in every year you are updating this value, you can, for example, select the data and to know how many people was living in Bulgaria at the specific year. So the values, the period start time is lower between the search date and time is greater than period start time and of course is smaller than the search date time. Let's go to the next. Contained int, start time, end time. All the data that were opened and closed in the given time range. So actually the search start date time is smaller than period start time and the period end time is smaller than search and date time. It is a recommended clause when searching for history versions only. And we are almost finished. So you have the from start date time to end date time. And you can see here what data you will get. Of course, the last way of using data is between, where you can specify the between start and end date time. Okay. Let's try to see some demo about that. So I have here a test database. I don't have any table for now here. And I want to create a system version temporal table. The way to create this table is like creating a normal table. The only difference is at the end. So you can specify with system versioning on. Okay, let's try to run this query. If we run this query, we will get an exception. Why? Because we didn't meet all the requirements. So it is required actually that we have a column valid from. You can, of course, change the name of this column. That must be generated always as row start, and of course, not null. Secondly, your table has to have a valid to column. Also, a date time to column generated always as row end, of course, and not null, of course. And the third requirement is, of course, to have a period for system time. And actually, this is a time span from valid from to valid to. And then we can create system versioning table. Let's see this table. Okay, the table is created. Let's refresh objects. So, sorry. Have some problems with shortcuts. Okay, I want to show you. So the table is created and is completely, and as you can see, it has this symbol with the time. So I think that this system has problems with magnifier. I'm very sorry. I must find a way to kill this. I think that Restream has problem with magnifier. I'm very sorry. So let me repeat this. So our table drinks is created, and you can see here the clock with the near the table. So it means that actually this is a system version table turned on. Secondly, you have this history table. And since I didn't specify the name for this table, I just tell to the system, give me a system versioning table on. So it is created by the default name. The default name is MSSQL temporal history 4 and the ID of this object here. Notice also then the history table. Just let me open this and hope that you will be able to see it. It is by default page compressed. So all the history tables are by default page compressed. If you check the structure, you will see actually that the columns ordinal position are completely the same for the main and the history table. Okay, let's try to drop a column. So I dropped a column from the main table. Now let's first refresh the main table. You see that the is alcoholic column is not anymore here. But what happened here? Let's refresh also this. Notice that the column is missing also here. So we will never know in this case if there was this column and what values it had before. So the schema is totally the same. Let's add a column. We did alter the table, we did add a new column, and now when we refresh, we will see this is the new column, and also in the history table we have the new column. So it's totally the same. Okay, let's now create a second table, also with history, but now we can use the history table and define the history table name. Okay, let's refresh our tables. So price list has price list history for the history table. So the system allows us to specify the name of the history table, of course. We have another feature here. We can specify history retention period, for example, 1 month or 1 year. What does it really mean? If we change the data in the database, and let's say that we created a history retention period of 1 month, we will actually, when we type from in the system, select star from a table, we will get only data that are changed prior 1 month. So the system will not return the data older than 1 month, even if we have them. So one important thing, the data are not self-deleted from the history table. The data are remaining in the history table, because if we write, for example, select star from the history table, we will get also the data before 1 month. But on normal usage, the system will pretend like these data are not existing. And if we want, for example, to delete these old records physically, because, for example, we have storage problems or something like that, then we must delete them by ourselves. But there is still one problem about that. So actually, we cannot delete history data. History table is only read-only. So first, we must turn off the feature, delete the history data from the history table, and then turn the feature back on. And while we are doing this, our system is offline. Okay. Let's see how can we create the history version table on, for example, existing table. So we have a non-history table. If we see here tables, we will see that it is a normal table. It doesn't have the clock here, and it doesn't have a history table. Okay, so what we can do as database administrators or developers to turn on this feature on existing system. First, we must add the two valid from and valid to, and of course the period of time. Okay, let's see what happened. So we have now valid from and valid to, and still the table doesn't have a clock. Let me refresh one more time if you don't believe me. Okay, and secondly, we will turn this feature on. Alter table, non-history table, set system versioning on, and the name of the history table. When we do this, now if we refresh our tables, we will see, of course, that it changed, and now it is a history table supported. Let's add two new columns, quantity and remarks. Of course, this is okay. And now in our columns, we have the, let's refresh it, the quantity and remarks. Oh no, price list, sorry. Okay, I am still working on this. I am confused a little bit. Sorry, so we now have the quantity and remarks. As you know, here in the history table, we also have quantity and remarks. Let's say that the we want a total. Total is a computed column like quantity multiplied by price. If we try to do this, we will get an error because system version table schema modification failed because adding a computed column while system versioning on is not supported. Okay, what can we do to solve this issue? First, we must turn off system versioning, of course. And now, notice here, when we did this, we have two normal tables. We have the price list table and the price list history table, and they are not connected anymore. We even don't have the clock here. Okay, let's alter and add total as quantity per price. And now we have in the main table here like total quantity per price. Let's alter also the history. We must add the total into the history table. Now here in the total we have here in the history. Let's update the records in the history table. Now we have values here also. And now let's turn the system versioning on again, back on. If we refresh again our tables, we will see that price list, it has normal history table and all the columns are here. So we have a total here, and here total is not a computed column, it's a normal column. And this is a normal feature of history system versioning tables. Okay. Let's go deeper. So let's create one plain table. And that's not history. With this select here, we can see all tables in the system and if they are history tables. Notice that we have is temporal history retention enabled on. Yes. Temporal table schema DBO, temporal table name non-history table, and here we can see if history retention period is on, of course. History retention period unit description is infinite because all our free tables don't have, of course, specified the retention policy. But if I select this without this where, I will get also other tables. Some of them are not history, for example, like this plain table hasn't a history table schema. Okay. Let's try to drop a system version temporal table. So if we try, of course, to drop a system versioning table, we will get an error because this is not possible. So it's not supported to drop a system version temporal table. How can we drop it? Of course, we must first turn system versioning off, and after that, we can drop normally the tables. Okay, let's go to query some system versioning table data. We will create a test table. We will turn on system versioning. We will insert some records. We will delete one record. Let's update something just to have more data. Let's update also something. And now let's see the data, how it looks. So this is the main table. We have only 3 products and they are all valid from the last change. Of course, juice was changed in ending in some 4 seconds of 1 hour and 37 minutes. Of course, and this valid too is the max value. So these 3 records are of course valid. Gin tonic and coffee were changed pretty much in almost the same time, not exactly, but notice here. If we look at the history, price list history table, you will see, of course, that umbrella is here, but the umbrella does not exist in the main table because I, of course, deleted the only umbrella here. And we have, this is the only actually record that you can see valid from and valid to. So I inserted first time umbrella here and I deleted it on this time here. For example, gin tonic, this was this 7 updates here. I can see every time when this record was changed. Of course, this was the start when I first inserted this record and then when I changed them. So actually here, sorry. I inserted it here and I changed it here. Okay. Also for coffee, I inserted coffee here and changed it here. So actually we can search for changes in the data. Let's say a predefined table in World Wide Web importers. So we have here a table with some countries. For example, Australia. We know the formal name, Commonwealth of Australia, and we have the latest recorded population. Okay. Let's see also all other countries, for example. You will see that we get only one record by every country because this table contains 190 countries and latest recorded population. But when was recorded this population? Let's see for our Australia. So valid from in 2015 in July, if I'm right, the latest recorded population was, I don't know, 22 million, so no, 2 million, 22 millions and something. Okay. Let's see, by using this syntax for system time all. So I want also to get all the data for Australia. Let's see this. Okay, I have now 3 records. What happened here? So actually, on 2013, in January, there was 21 million and something. Okay, then we had a new screening in 2013, half year later, almost. We have 22 million and something. And latest, in 2015, we had this active record now, and we have almost 23 millions of people. So these are all the records in the main and the history table. See the execution plan. Notice here that 2 tables were scanned. First, this is the main table. Secondly, we have the history table scanned. And this is a concatenation. So all the records from 2 tables were concatenated. Let me repeat the first one. Sorry. So I want the current data. If you look at the execution plan of the current data, you will see that only 1 table is scanned. So the system is clever enough to see the current only table. And if you see at the messages here, you will see that only table countries was scanned. But if you specify for system all, then the main and the history table are scanned. So here in the messages, you will see countries archive and countries. So both tables. This is completely the same approach if I, for example, write this, select some columns from application countries, and then union all, select the same columns from countries archive. Let's run this query. Look at the messages. We have country archive, countries, so 2 tables were scanned, and in execution plan you will see the same situation like before. First table, second table, and concatenation. So the system is working by itself. And we will try to see. I'm wondering what was the latest recorded population, but in 2013 and on this date for Australia. So it was 21 million and something. What happened with the tables? Of course, countries and countries archive was scanned also. Execution plan is the same. We can get, for example, if we don't specify the where, only the first part of the query, we will get for all the countries in this period of time, how many people were there. Okay. Let's try, we return to our test database. We are trying to delete records from the history table. So this is not possible, of course, because only the main table can be deleted if system versioning table is turned on. Let's try to truncate something. Also is not possible. So we cannot truncate neither the history table, neither the main table. Alter the schema of the history table. Let's add a column. This is not possible, of course. We will get also an error message. Let's try to add a trigger on the history table. This is also not possible. So you cannot add after insert, delete, or update trigger on history table. Okay, and one more thing, and this is the last thing in this demo. If, for example, as I told you before, have a system on which you want to turn on this feature, but you don't want actually that the user see these new columns, because maybe you would break something like an ORM or something, then you can specify the valid from and valid to with hidden statement. So you have this hidden. Let's create the table. Let's insert some demo data. And if we select star from hidden, we will get only the drink name and the primary key ID. So we have only two columns. Let's find this table here. It's called hidden. If we look at columns, you have 4 columns, and select star, return only 2 columns. So the way, if you want to get these columns, for example, to see what was the state on the some date or time, then you must type their names because they are hidden. So if we select on this way, we will get all the columns from that. Okay. And actually, this is all from me about the system versioning tables. I hope that it was instructive and that you enjoyed. I should wait a little more if there will be some questions, if I can help. Otherwise, I will leave you for the rest of the conference here. Okay. Thank you very much, everybody, one more time, and have a nice day. Bye-bye.
Hi. Hello, everyone. Just a final last check. Okay. Hi, everyone. It's a pleasure to be part of this community. It's a pleasure to contribute to the initiative of Mikhail Matev and the Global AI Bootcamp 2021. I will start my presentation on a concept that I've been exploring for the past 4 or 5 years. Some of you who knows me, you may know that I'm not, restreaming the same presentations, but I do upgrade previous ones. Okay. Today we're going to speak about digital twins. I'm going to share a little bit about myself. I have a PhD in computer science. I'm
sorry to interrupt you, but I'm seeing the second monitor, not the right one. You have to switch them.
Okay.
Sorry again.
No problem. 1 second. How about now?
Perfect.
All right. Okay. So guys, again, I have some experience with IT. I have some experience with energy. I have several years of working in the domain of renewable energy. And right now we're trying to explore what we can do with the amazing field of AI and IoT and basically all kind of tools that we can apply to modern reality. So, 1 second. So we're going to talk today about the actual role of AI in grid predictive maintenance. By grid, I'm referring to electrical grids. We're going to explore why do we talk a lot about grid and what exact tools and what exact questions we've encountered. My request for all of you will be to challenge your mind and basically give us a feedback on what possible applications you may find, and please feel free to reflect on anything I'm going to say. It's more of an exploration exercise. So when I present, we'll have plenty of time for at least 10-15 minutes for any questions that can come to mind. The reason I talk a lot about the grid is that the new transformational trends related to something as stupid as mundane as electrical utilities is finally entering an unprecedented time of disruption and change. And it's all been happening for the last 5 years. Anything from decarbonization initiatives, renewable, electrical vehicles, it brings a level of complexity that is not only something that it's good to address, but it's life-threatening to the core existence of sustainable supply of electricity. On top, when we add a lot of regulation, a lot of hassle with financial pressures, utilities have to invent new things, to invent revenues just to stay competitive. What we now are seeing is suddenly a convergence between something as simple as electrical wires and new technology that's pretty much redefining the whole landscape. When we talk about landscape, it's not a unidirectional thing anymore. So what you would normally see, the thermal power plants, like nuclear power plants, they're basically making the energy, and then the energy goes one way to our homes, factories, cities, offices, etc. Right now, you have a mesh of interlinked consumers, prosumers, which is basically creating so much instability that the ecosystem finally looks something like that, right? Before it was a line. Now, currently, it's a network of interconnected devices, electrons, power generators, power consumers, and also storage, which is a new thing because the number of electrical vehicles is expected to grow. Based on data we have, we're experiencing anywhere between 5 to 225 million units up to 2030. And, you know, for example, if they all charge at the same time in the existing network, it will literally break the grid. And add the construction of charging devices and, you know, all the complexities that are behind that. And the reason I'm saying that's so complex is, on one hand, it's important not to break what we have right now. On the other hand, it's not possible to do it first and then see how it operates. We need to find a way to simulate it. We need to find a way to basically predict what's going to happen, not only from security perspective, but also from financial perspective, right? So they can, you know, also defend the business need in front of regulators, clients, consumers, because basically anything we touch will affect the end price of the electricity. Okay. As again, what we see right now is a transition from, you know, a bill payer, a traditional consumer of electricity, to prosumer, which basically creates another layer of complexity that's also an advantage for utilities to be able to involve their clients as an updated part of the value chain, where we as a client can basically contribute back, not only by producing electrons, but also by actively involving ourselves into decision-making that allows the utility to create more revenue streams. So basically, the purpose of the slide is to illustrate that the power now is not with the utility anymore, it's also with us as consumers. The reason I'm talking a lot about the importance of the grid and why this is now so interesting to connect to the whole world of AI and IoT is because we often underestimate the importance of it and the actual nature of it, right? So basically, that's the grid. That's what we see. That's probably the most mundane and commoditized item you can see out there. And we never saw that we're going to deal with weird questions, because right now, when we're trying to figure out how to analyze it, how to collect data on it, we tend to forget that it starts with data acquisition. And this is actual footage of what we do as part of our initiative to collect information about the grid. And this is what we have to overcome, because contrary to other assets such as machinery or, you know, water pumps, this is something that's super huge, super vast. And this is also something that, to be able to collect data about this and convert it into that, it takes a lot of effort. And since my previous presentations in previous AI boot camps were mostly about how we gather data and how we make digital models of what we basically collect, the purpose of this conversation will be today on not only how we gather data, but what we do with the data. And basically, not only how we measure what's happening with the grid, but how we use that to predict. From previous presentations, as you know, a part of our data gathering exercise in Bulgaria, Romania, and a few other countries now has been using drones and a platform, which I'm going to demonstrate a little bit later today, which allows us to automatically annotate and collect data on important grid elements, right? So we're able to classify it, we're able to analyze it, we're able to automatically connect to GIS systems and basically provide people with decision support analytics, allowing them to estimate what they have to do just to repair the grid. Now, the new approach which we're discussing today, and hence the digital twins concept, is how do we predict what is going to happen before it happens? And this is where the big data analytics come into play. And one particular problem that we have with big data analytics is that nowadays we found out it's not about what data we acquire, because we kind of learn how to acquire data, we've learned how to analyze it, but how to connect the different data silos. And the importance of that is that without, remember I mentioned the complexity of the new grid, without a smart grid approach, the overall costs for grid balancing, grid management, and just grid securing may go like 4 times, while basically we can, keep the costs within certain parameters and still be happy with the grid. The one problem on the big data analytics, once we start collecting the data, once we start dealing with that data, is that if you take a utility, which is not a natural IT company, the problem with the utility is that the different departments, they have different needs. And we've seen it for the past 4 years, dealing with different utilities, electrical utilities, trying to apply the concept of digital twins, is that different departments, for example, the network maintenance, network planning, the GIS department, and IT have completely different specific views of the grid, which creates the so-called data silos. And, and they cannot interoperate. Basically, the problem with the grid, if they cannot interoperate, they'd rather not do it because they would weigh that against the risk of doing something to the grid. And, the primary concern with that is that this is number one problem that basically prevents any IT to go into the grid nowadays. So what we started doing is started to look at scenarios of and business case models and tools which we're going to discuss today. What can be done to reduce the inefficient business process and also eliminate the manual data sharing, and how to figure out to unlock new services and revenue models, which we believe are vital for the survival of the environment because of all the pressures discussed further. The main important thing related to digital twins and AI application is to eliminate those data silos and achieve a data of interoperability, because this only then we can simulate future events, right? To reduce costs and achieve new levels of competitiveness and whatever. I mean, the more simulation we're able to achieve, the less guesswork we need to invent, which basically reduces human errors, repair works, and help achieve all the targets on energy efficiency and loss reductions on regulators. Now, to create all that, the IoT devices, whenever they have it, and cloud-based data management platform need to be implemented to be able, to support the utility operator, so they don't have to argue between the network planning department, the operations department, the IT department, what kind of data needs to be shared. And we need the new concept, which is the digital twin concept. Again, if there are questions, what is the digital twin concept? Well, let me know. Basically, this is a simple digital representation of an actual grid, right? And again, the multi-directional flow of power and data, it suddenly required a comprehensive look on how the whole system operates. And it's something we found out it's only through AI and machine learning algorithms you can really encompass the whole of it, because they're so diverse. And this is so important not to break it, that we need an environment that's able to simulate what's going to happen if you do something on operations, how it's going to affect planning, or if you, change something just to optimize, you change an asset, you also have very, very strict constraints how it's going to affect the financial underlying number, right? So the chief advantage of that approach, of the digital twin approach, is that we're finally able not only include assets, because we learn how to do it anyways right now. We can provide the electrical grid with remote reclosers. We can provide them with temperature sensors. We can provide them with tension sensors. We can provide them with cameras. We've been using drones to control the visual status of the grid. If we have like missing elements or bad vegetation, or corrosion, or hanging wires. But this is not enough, right? I mean, this only gives us a picture which allows us, based on common sense, to plan repairs. What I'm trying to concentrate also as a business, not only as research, is how can we achieve predictive maintenance, right? So basically, this is the chief advantage of digital twins. You can not only include assets, which you see on the screen, you can include other factors that are relevant for the simulation. It can be seismic models, can be weather data, can be any kind of information on the material of the assets. For example, we've been now experimenting with if we provide data on the metal and combine it with weather data and combine it with seismic data, how can we estimate the life cycle of the specific power pylon in a way that if we hit it with the blizzard, we'll try to forecast what can happen to it. And what I need to say, that is, the concept of the digital twin has been around since maybe 2000, but only the past 4 or 5 years, because of the advent of the industrial Internet of Things, industrial technology and operational technology, it's finally cost effective to implement. And we'll have a discussion about what Microsoft is doing about it, which also helps unlock, an important part of the whole approach. Okay, so the important thing of the discussion today is to analyze what kind of areas of applications of AI may exist on the grid. So basically, the point is that the operational digital twins, they provide an insight what is happening right now on the grid. What we're trying to achieve is predictive digital twins, basically adding more dimensions to the asset base. It can be, statistical rules-based method, heuristic techniques that can identify constraints and how to deal with them. But what we're trying to experiment right now, and this is quite new, especially when applied to something as common as electrical grid, is a combination of supervised and unsupervised machine learning. Basically, to try to figure out what predictive and prescriptive values are important to control in order to understand what's going to happen to the grid. The beauty of that is that we're still surprised because this is something that's largely undefined. There are several companies in the world that are right now trying to do it, but it's still largely undefined. And the reason it's undefined because we didn't have the tools up until 5 years ago to be able to model cost effectively and connect more factors outside of the asset base. So basically, the idea now that we have is to combine various model approaches, various machine learning models, to help achieve better and better predictive accuracy. So again, the pivotal aspect of being able to do that is finally we're able to utilize real-time IoT data to basically try to figure out what can happen, predict events before they occur. We had some pretty good examples until now. Whenever it comes to prediction of weather initiated failures, such as failures of wires, or what can happen to, if like a single power plant falls. But we're looking towards, more examples. Again, my personal research right now is mainly in the maintenance and repair section. That in Bulgaria, we have some pretty interesting examples to share. How we do it? We rely on artificial neural networks. Basically, again, what is an artificial neural network? It's basically the closest we can have to a human brain. It can be feed-forward neural network, convolutional neural network, deconvolutional neural network. We're mostly trying to experiment with GANs. I had my previous lectures on generative adversarial networks and basically how to have a combination of several neural networks to fight with each other to be able to achieve a better accuracy of the data we acquire. Again, the kind of data we acquire is basically image data for the time being, and to be able to save us machine time, we've been applying the concept of GAN, generative adversarial networks. I had one of my previous lectures was on that specific topic. If you want to explore more on the GANs, well, just let me know and come back to me. I have my coordinates in the presentation. Coming back to how do we do it nowadays? And what are the constraints to the application of the digital twins? The biggest constraint is how you collect the data, but even greater constraint is what do you do with the data? And this is where Microsoft, I think, did an amazing, employed an amazing approach. They developed a toolkit starting with the Azure Digital Twins, which basically is an IoT, it's an Internet of Things platform that helps you define a digital representation of real-world things, almost in real time, process people, and rely on a huge library of insights that have been contributed by other people. So it's an open modeling language, so you can create custom model of any complexity, basically using something called Digital Twins Definition Language. You can simulate execution environments. Microsoft is doing an amazing work doing a graphical representation of that, plus connecting to another product by Azure called IoT Hub. It also allows you to connect to literally thousands and thousands of IoT and business systems, any kind of IoT device. And we love how we do it. So there is no upfront costs. It's no termination fee. You basically can fine tune how to use it and how much time you need, how much machine time you need to the specific concept of your specific problem with the grid. A connected tool that I highly recommend to explore, it's the Azure IoT Hub. It's basically a secure and super reliable communication layer between your application and any device you can imagine. So it's bi-directional communication with literally billions of IoT devices. It's device to cloud telemetry data, so you can understand the status of your devices. You can basically authenticate every single device if you need additional security, which is one of the problems with modern IoT devices, where people just hack them and use fleets of thousands of zombie devices for other purposes. And basically what you can do is you can automatically figure out pretty much any device on the device level. The beauty of that approach is that you can also rely on a whole host of Azure products, including the IoT Edge and, most importantly, the Microsoft Azure High Performance Computing. because one of the problems that we have is that we don't have an upfront requirement to invest into expensive infrastructure, and we can optimize the GPU, CPU, bandwidth, memory, and fine-tune it exactly to the kind of business case that we need to sort out. So basically, take that as a built-in AI modeling tool with a built-in DevOps. I'm gonna run a small demo of what we do for the data collection, and then I'm gonna run a small demo on what GE is basically doing in that domain, which will illustrate basically what I said, and then we can have time for questions.
PowerDrone is the data analytics technological company using drones and specialized software for an automated power line inspection and other energy assets. Utility and energy companies have to inspect their assets on a regular basis, and they face lots of challenges. The usual on-foot inspection is slow and costly. Areas are hard to access, and grid elements are not properly inspected. The manually collected data is difficult to process and analyze. We are helping utility companies with their regular technical inspections, especially in hard-to-access areas, where we can secure full accessibility to any inspected object and collect high-quality data.
This is the actual footage from actual power lines in Bulgaria.
The platform can be approached remotely from any point of the world and provides access to the entire analytics and processed imagery data. With our software solution based on AI and machine learning algorithms, we are able to process high-quality data. The application of AI and machine learning algorithms make possible the automated recognition and classification of the different grid elements without a human interaction. The software successfully sorts out the images for the given object, defines its precise GPS coordinates, and defines all attributive and technical information. To secure highest precision, the processed data is validated by an expert verifying the software findings and retraining the algorithms. The excellent visibility and precise identification of the problems point out clearly the need and priority for preventative maintenance, saving substantial budgets for emergency repairs and unwanted shutdowns. On top, we help minimizing the quantities of unsold electricity and unhappy customers. PowerDrone is aiming to automate as much as possible the entire workflow, both in terms of automated data analytics and autonomous drone inspections.
Right. So the point is, and I want to run like one last video before we switch to actual discussions. I can explain what we do in Bulgaria with the digital twin prospects and what kind of elements we try to utilize, and I would expect any suggestions, basically, what we can do and what other factors we can collect. The demonstration you saw is actually where we sit right now. We sit right now on on collecting the data. What we're experimenting right now is also how to automate the data in a way to, for example, predict if the temperature falls under certain degrees of Celsius, like under minus 18, like what we have today in the mountains near Sofia. And the humidity of the air is such, what will be the result before a certain part of the grid will start falling down. And just to illustrate what GE has been achieving in that respect, I'll try to play a small video that basically it's 1 minute and a half video explaining what big companies are doing.
Time of disruption and change. Decarbonization is driving the adoption of decentralized renewable energy, which in turn brings complexity to the grid with a multidirectional flow of energy and an increasing number of connected devices. Utilities are looking to digitalization to increase innovation, reduce cost, and manage risk. Traditionally, electric utilities have operated in siloed organizations where each department, for example, network design, has a separate and specific view of the grid. In order to meet the challenges of the modern grid, utilities need one comprehensive view. This approach reduces inefficient business processes and eliminates manual data sharing. And as a result, utilities can harness the benefits of digitalization and provide more innovative services. The Network Digital Twin from GE provides a comprehensive view of the grid combining GIS, EMS, and ADMS, all powerfully shared across the utility. The Network Digital Twin is software that connects physical systems on the grid with the capabilities of the digital world. It is the digitized version of the living organism that the modern grid has become. Network Digital Twin accumulates data over time about the structure and location of assets, their operation, and the environment in which they operate. On top of that asset data, valuable intelligence is developed using analytics, physics, and continuous machine learning. Past and present asset performance and operation are stored as part of the digital twin and can be used to predict future outcomes. The Network Digital Twin builds on the breadth and depth of GE Power's software solutions. And thanks to the power of Predix, GE's industrial internet platform, critical business insights and intelligence can be used with edge devices, on-premise, and in the cloud. With the Network Digital Twin, multiple data sources can be fully leveraged to simulate and predict how the grid can be optimized.
Now, what I wanted to interrupt here is that, GE is a huge company, and a lot of you may say, well, what do we have to do with it? So my point is that now leveraging Azure services, by the way, we started playing with Azure Cognitive Services, which allowed us a much better and faster image recognition. Now we can also pretty much develop the same model, from home. You don't have to have a complicated machinery. You don't have to have complicated access to devices. There is a number of third-party devices. So basically, the point is that you can achieve the same result by scaling smartly your resources and providing a comprehensive service. I'm going to stop here. It's a very, very broad topic. Right now, I'm quite interested to hear some feedback on what you think, if you know some examples of application of digital twins specifically in electrical grids. I'd be super happy if you can share them. Ask me any question. I'll try to answer them. And yeah, going back to thanks to our sponsor, which is Microsoft for today. Able to make this presentation. And again, I'm very thankful to Michael Matev for organizing this event in those hard times. Yeah. I'm going to wait for a few questions. Okay. Is the drone take photos on its own automatically? Right. We already know basically the angle, what we need to collect. The drone is taking a lot of the input data automatically. Yes. The point is to have numerous overflies. So basically, once we fly over the network, and because it's there, it's easy for us to just predict what we need to collect this information second time. So the whole purpose of using drones for data collection is to automate the operation and eliminate the human in the loop. The only humans we have right now, they sit between the algorithms for automatic image recognition, and whenever we have an error, we have a human correct it, annotate it, and improve it. But collecting information with drones is now becoming quite an automated exercise. And just note, it's so funny. We're discovering more and more items now, like use cases, what we try to do with the grid. For example, we've been able to predict if you have two pylons, what happens in the winter when we have three pylons, one of them falls. When they remove the middle pylon, they just extend the wire. We learned how to predict if the fire will touch the ground or become a problem in the summer, because even with aluminum wires, we found out that if you have an average space between two power pylons on the middle voltage grid, which is normally 70 meters. If you remove a pylon in the winter, you can still, stretch the wire so it sits between two pylons, which becomes 140 meters away. What we found out that in the summer, because of the temperature, the wire can actually hit the ground, and we can even see it from space. Now, understanding the material of the wire and the temperature outlay in the region, we can even forecast if you will have problems if you will have problems with the wire becoming dangerously close to the ground. Last year alone, we found out, you will not find it in newspapers. Last year, we found out that at least 10 people died in Bulgaria, in electric utilities being electrocuted because of this problem. And then I can talk a lot about such problems. So the purpose again of the presentation was to indicate that we can finally have the tools, the means to apply real AI to something as simple as electrical wires. And I'll be very happy if you find me and you follow up with me when it comes to other questions. So this is my information on the screen. So if you have any kind of questions, let me know. Okay, I'll leave it on the screen. Thanks to the organizers again, and hope to see more of you in person. It's very strange to present without an audience.
Hi.
Hello. Can you hear me?
Yes, I can hear you well. Now we can see your presentation also, and I'll leave it.
That's great. Thank you very much. So welcome everyone. The last talk during this global AI community event will be about automated machine learning. We are starting a bit earlier, which is great. That means that I have slightly more time to talk to you. And that's actually one of my favorite topics, this AutoML. But to be fair, I will try to spend at least 5 minutes at the beginning just by small talk and introduction stuff like that. So hopefully you will all be with me when we move to the technical part, the most interesting part of this presentation. So automated machine learning, or how augmented machine learning is democratizing data science right now. That's the topic. And first of all, I would like to thank not only Microsoft as a partner of this event, but also Bulgarian BI and .NET user group and Azure user group in Bulgaria, because I know it by my own experience that organizing this kind of events right now is even harder. Yeah. So unfortunately, I'm not with you in Sofia. I've been there a few times, thanks to Mikhail Matiev. But still, virtual event is better than none. Yeah. So that's the case right now. By the way, it was always great to be in Sofia and talk to you in person. But right now, after this year of COVID-19 lockdown, I can appreciate even more. Yeah, so that was really great. Thank you all. I'm talking to organizers, Mikhail especially, and partners as well. And thank you actually, because without an audience, those kind of events will be pointless. So I know it's getting late in Sofia right now. It's Saturday. Hopefully you will stay with us. So who am I? I'm Marcin Szeliga. I'm from Poland, from Silesia to be more precise, so the south of Poland. I've been working with thank you. Hopefully that will be soon. I've been working with Microsoft data platform technologies for more than 20 years right now. So I saw this platform growing. I'm a university teacher right now, MVP and MCT. So I'm delivering a lot of those courses, but I'm also still working as a data platform architect, let's say. Right now it means not only machine learning or artificial intelligence, but business intelligence. So let's call it advanced analytics platform. And I'm doing a lot of those projects. So let's say I have a first-hand experience, not only those certifications, stuff like that, or books. By the way, almost exclusively written in Polish, so probably not very useful for you guys, sorry. But I put it on this slide to introduce myself. So I promise that after 5 minutes, we will be ready to switch to the presentation. Actually, that's the case. The agenda for this session is just 4 points. We will start talking about machine learning lifecycle, how it looks like traditionally. Then I will try to convince you that data pipelines are great. And afterwards, that machine learning pipelines are even greater. And so I will show you those AutoML pipeline in details. And actually, that will be it. If you have any questions, please let me know via chat window. Hopefully, I will be able to answer them immediately. If not, at the end of the session, we can also allocate some additional time, a few minutes to talk with you. Because actually, from the speaker perspective, it's also not the best experience just to talking to a mic. Yeah, so talking to people was far much better. Okay, so the machine learning. I'm going to. So my assumption is that you know what machine learning is about, more or less. If not, let me know. But in theory, it looks like that. We should start with data. So the historical data. Data is always about past, by the way. But we can use this data to predict future or current state. So that's something very unusual, yeah. So we are calling this data training examples. That means that actually the model is pretty simple used across all those machine learning experiments. It's just a flat file quite commonly. So no tables, no relations at least, yeah. Just a set of variables, we are calling them input variables or features, and a single, that's the most common case, output variable, also called a label. And based on this, we are building some models. So we are applying those fancy maths to this trained data to find out some correlations or hidden patterns in this data automatically. That's at least in theory. In practice, it's not the case, as you will see soon. The trained model then is being used for predictions. I'm talking about predictive analytics because that's the mainstream right now. So we have a brand new data, new observations, and we want to ask a question about this output variable. For example, is this customer is going to leave us in the given time frame, or I don't know. There are many possible scenarios, as you probably know. I'm going to show you a basic Kaggle competition, by the way. So one of my questions that we are going to discuss is, was this person going to die during this Titanic catastrophe? And the test model, because we can assess the model effectiveness, the quality of the model, even automatically, should be deployed and used for predictions by our user. So that looks good. In theory, it's a very simple process, isn't it? But if you try to do something like this, by the way, right now, if you want to work with machine learning, the required skill set are Python, as you can see right now, SQL. So I saw one of the previous comments that SQL is not the best. Not everyone likes SQL, but to be honest, there is no best way right now to work with a large amount of data. So quite common approach in those modern warehouses is to use SQL on top of files, Parquet files, quite often. So Python, SQL, some modeling skills will be nice to have. You will see at the end of my presentation. So I try to implement this simple process. So that's my trained data, and I have even a test data to assess my model quality. I divided this data into input variables, so features, and then the output variables, so a label, and then from sklearn, quite popular framework for machine learning, I try to split the data accordingly into train, test, split. So as you can see, this test is actually a different kind of test. It's a validation data set, okay? I'm not going to use this data more than once at the very end of my experiments. In this case, just by uploading my test data frame to Kaggle to get my score on the leaderboard. So it's like that. But still, I would like to apply the best predictions, so the best predictions made by best model. So I have to test my model accuracy on my way, yeah, as I'm progressing. So 3 data sets are actually needed. Then I'm trying to build a, I don't know, logistic regression model, why not? And I got something like this. An error due to some variables type. So looks like this approach actually is not the best one. And I can tell you that sooner or later, you can even manage to succeed. So build your model. You can switch to R. R is less picky about data types. Or you can use one of those no-code, low-code environments. They also deals with different data types automatically. But still, let's say that we manage. We build this model, and I uploaded my test data frame, so the predictions actually, to Kaggle, and I got a result like this: 62% of accuracy. And that was my position on this leaderboard, yeah? What does it mean, actually? Was it good? Was it bad? If we take a look at the output variable distribution, we will find out that about 62% of passengers died in this catastrophe. So the accuracy of our model is very close to random guessing. If the model would say no, 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 and that's it. So the simplest possible machine learning model, yes. It's not everyone likes SQL, but you will see that it's still great. It's one of the oldest programming languages still used and still very popular, on the top of most popular languages. So that means something. So if that would be the, yeah, I will show you the code. Maybe I will even share the notebook with you afterwards. So no worries. But yeah, I do remember right now. I will zoom my code even on PowerPoint slides visible. So if the model will be just saying 0, the simplest model, answer 0, I will get the same result. So it's not very intelligent approach, yeah? Why was like that? Because in practice, machine learning experiment looks completely different. So first, we have to cleanse our data. And data cleansing and feature engineering are most time-consuming tasks. You can, probably you have heard the term data wrangling. That's the part, yeah? And data scientists, all of them are complaining that majority of their time, like 80% or so, they are spending with data wrangling, which is actually not good and not totally true, because they should spend more time talking to users actually at every stage of this experiment, especially at the beginning and at the end, not just sitting at their desk working with data or algorithms. I know a lot of people are this kind of people, but actually in practice it will not work. You will get a better career in data science if you can talk with people. Yeah? If you can spend some time talking with them and present your results efficiently. So data cleansing means dealing with missing values or normalizing values or dealing with outliers, stuff like that. Feature engineering is about enhancing the data set, the training, the data set, generally speaking. So like computing additional variables, why not? That can better represent the problem from algorithm perspective. There are just algorithms. you should know how they work. If you know this, you can prepare or enhance data accordingly to those algorithms' needs. And you have to do this manually, let's say, right now. Then there are a lot of those machine learning algorithms, which is the best in this case. Who knows? You can use your intuition or experience, but still it will be like a guessing. Yeah. Even worse, those algorithms takes parameters. Those algorithms take parameters, and they are called hyperparameters because you have to set the values of those hyperparameters in advance. You are designing the model structure, the model architecture right now. Those hyperparameters will not be learned automatically from data. And some of algorithms have a long list of those hyperparameters. So based on this, we are building some candidate models, and finally, we decided that the metric used for evaluation in this case will be, I don't know, accuracy or whatever else. There are a lot of them. And you should choose this single metric very carefully. It's very important. And based on this metric, you can say, okay, that's my base model. I'm going to deploy it and put it into production. So looks good, but now the path is longer. Looks like it's more like engineering project. Yeah, at the end it's just a code, and we have a code to learn, a code to use the model, and we have to work with this as a code. So DevOps right now, or even MLOps, is the right solution. So what does it mean actually? Do I have Zoom? Yes, I have. There you are. So the second approach, how to implement this in plain Python, actually, you can do this better. Even I can do this better, but I'm not a Python programmer by itself. So again, the same train test data set, but now we are dealing with the data. That's just a subset of things I did, okay? There were more. As I said, if you want, I will show you the whole notebook afterwards. So I checked or decided that ticket, cabin, and passenger ID are not useful. Passenger ID is not useful for sure, yeah? So I dropped those variables, and then there was a name, and the name actually by itself was also useless, but it contains interesting features like a title. So I extract the title from the name and replace the name with the title, and I did a lot of more actually. Like I add additional variables like family size or is allowed by combining some other variables. So that's actually the long list of instructions just to clean and prepare data. Afterwards, I was imputing missing values. You will see. But let's have an overall picture right now, okay? So what's going on? How to implement this? And actually, if you follow this, you will get much better results. Yeah, now my position is way higher. My results are also better, aren't they? Actually, that's the close to the max you can get without cheating with this Titanic. So those guys above me with 100% accuracy, I'm a little bit suspicious about their results, actually. Maybe they just look out the output, the true values from Wikipedia or whatever else, I don't know. So this actually works, and you can do this. So, but maybe if you think about this, right now looks like machine learning, which is supposed to be a field dedicated to automatically learn from data, looks slightly different. Now, the result, actually the best model, depends heavily on us, on humans, on data scientists, We prepare the data set. We add those features. We choose the algorithm. We tune those hyperparameters. So is it still machine learning or what? That's interesting question. Yeah, very good. Are you right now in England, by the way? Where are you? England, US, based in Bulgaria. So maybe, and that's the topic of this lesson, of this talk. Yeah, maybe we can automate this pipeline. And as you can see, there are different steps. Yeah, data preparation, experimentation or modeling. So choosing an algorithm, finding those best hyperparameters. And we are focusing on these two steps. There are actually, let's say, two steps. Forget during my talk about deployment and operationalization. They are very important, quite technical, so data engineer task, more than data scientist actually, but some tools can help you with deployment and operationalization as well. And now it's time to introduce Azure Machine Learning. I will switch to Machine Learning Studio right now even. So Azure Machine Learning is just a set of cloud services. So it's top-level platform as a service. Some additional resources will be provisioned for you automatically, like storage, like compute powers, yeah, like container instances to put your models somewhere, yeah, and publish those models, make them available to users. So set of Azure Cloud Services and Python and R SDKs. And actually Python SDK is the primary SDK. R is just a wrapper around this Python and still in development. I don't know if R SDK reached global availability right now or not. The Azure Machine Learning Service is with us for like 2 years already. So that's, as you can see, it's better to know Python than R right now. And with this, you can move from the very beginning to the end. So it's end-to-end service that enables you to prepare data, build models, publish those models, monitor the models usage, stuff like that. Okay? All from one workspace, all from Machine Learning Service Studio, which looks like that. So let me, if you don't ask me, I will skip the part about how to provision machine learning workspace. Yeah, that actually, as you can see, I have my Azure machine learning workspace up and running already. Some additional services are here. There are even more of them. I have at least in my instance in my Azure machine learning service. But the point is that you can launch Studio and its web-based environment. Hopefully now the phones are big enough so you can see them. And here you can manage some assets. So you have data stores. Let's start with data stores. Yeah. So you have data stores. You can register some data stores. Does SQL databases, data lake, blob storage, whatever you want, more or less, if it's actually in Azure. Otherwise, you have to import your data lake approach. And computes, yeah. So you can have compute instances. There are just local virtual machines. You can connect to them via Jupyter or Visual Studio or Microsoft notebooks. I will show you Microsoft notebooks. They are quite good in my opinion. More importantly, we have compute clusters, and you can build as powerful compute clusters, GPU or CPU based as you want, up to your threshold, yeah, because there are some threshold per subscription, and you have to pay for the usage afterwards. And that's two most important type of computes. So we have storage, we have compute, we have a workspace in which we can write our notebooks. Yeah. So we will be fine. Yeah. There is of course more. Yeah. There are pipeline experiments. You will see some of them during my talk as well. But okay, I think we have time, so I will show you slightly different scenario shortly. So we will start with this forecasting using AutoML. Okay. Now in this Titanic, we are at this stage, some more or less. So I just try to prepare my data. So can you see it? But actually, it's no point of reading it right now. Okay. So that's the whole data preparation part. Yeah, as you can see, that's this my is alone binary variable. I add to my input features, to my features list. Then I encoded the categorical variables into numerical ones that was needed. I try to impute missing values based on sex and PC class, so per group. And I divided this far into beans like that. And with this, hurrah, I managed to build my logistic regression model. And as you can see, my trained score is 84 and my test score is 78. So there is a difference, and that's usually the case. Training score is generally higher or better than test score. This test was done with training data. This test was done with test data, so data unseen during training. Okay, so then maybe I should choose a different algorithm, maybe this one, random forest. And my test score is even higher, but my train score is even higher, but my test score went down to 74%. So which model is actually better? This, more complex, or this, simpler one? And the answer is that the test score is at the end the most important score, yeah? Actually, this, you can quite easily get 100% here just by building more complex model. I will just remember all those training examples sooner or later. But ability to generalize, to be able to answer questions based on unseen data, that's what's matter, yeah? So it's like that. Okay, so that was the environment. As you can see, you can do something like that. That was still just plain Python. You can rearrange your code using those SDKs, and it will look better for sure. But actually, that's just for illustration purposes. Yeah. So we are at this page right now. We managed to build a model, and we know that the data preparation is important. Actually, they are saying that better data always bets or win with smarter algorithm, and that's true based on my own experience. So data preparation, important part of the process. Okay. But how can we automate this? What this automated machine learning is about? This is a very hot topic, and you should, if you didn't do this yet, you should start watching or working with AutoML libraries. You will find a lot of them. Here I'm using AutoML based built into Azure Machine Learning Service and Azure ML SDK, of course. Yeah, okay. I will try to zoom in again when I switch. But here, the important part is the text, that the AutoML is actually an answer how to find a good enough model automatically and fast, because time is precious resource. And I use this, but before I will show you this Titanic, now I will show you how I build a forecasting model using AutoML, even without explanation. So now I'm going to show you the result, and then we will talk how I achieve this result, okay? Because forecasting, if you think about this, is even more complex than classification or regression. In forecasting, we are dealing with time series data, and you have to take this time dependencies into account. I'm not talking only about autocorrelations, that's obvious probably, but also about trends, seasonalities, holidays, those moving averages, those lag variables. So there is a lot of things you should do with forecasting to get a good model. And I did this using AutoML. So let's forget about those notebooks for a moment. I will show you an experiment. This one, forecasting. Okay, so that's my experiment result. It completed in 19 minutes. And if I go here, I will see that I got some models, more than one actually. Okay. And the data quality was checked for me automatically. So there were 3 types of checks, like frequency detection, missing feature imputation, and short series handling. I passed those tests. So this is nice if you think about this, because that means, let me zoom in. There you go. Because if you think about this, that means that I don't have to code those data pipelines, yeah, and all those. If there is non-stationary time series, we should launch this notebook. If there is something else, we should do something else. A lot of coding. Okay, so I got some models. Let me start with the worst one based on this metric. So it's mean of squared errors normalized to the output variable range. AutoArima, classic algorithm. For sure you know them if you are dealing with forecasting. If I go to metrics, I will see that the explained variance is actually minus something. And the predictions looks like that. That's actually the best model based on test data. That doesn't look good at all, yeah, right now here. The distribution of errors, a lot of metrics actually you can see. So this model, I got those results, by the way, by intelligently removing some part of my time series for testing. This strategy is called rolling over cross validation. So that was used for me automatically. What about the better model? Maybe the best. Why not? This is ensemble model, which means it's more than one of those good enough models working together, yeah, to give me the overall prediction or forecasting in this case. If I go to metrics, it looks way better. On the chart, it also looks better, yeah. So that was the beauty of this solution. I actually managed to find good enough model that can be used by users. And I did it. Let me go to my notebooks, forecasting. Just with a single almost single line of code. Focus. Okay. But now I'm using actually this Azure ML SDK extensively. And I'm using one of those computes I showed you previously. Yeah. So it will launch, the experiment will be executed on remote compute. And you can have a compute cluster with large amount of nodes. So that's scalable computing. And that's my data, actually not that important part. I deal with some missing values automatically. And finally, the experiment is defined here. Okay? So this is actually AutoML. I'm not saying anything about those ARIMA or Prophet or deep neural network, whatever, long short-term memory network. I didn't use those concepts here at all. I just said that I would like to minimize mean absolute error. Okay, then I'm going to spend this amount of time, and I prepare data as I showed you previously. That's my cross-validation strategy, and I launch this experiment and wait for completion. Okay, so now the same story, but from the notebook perspective, and I got my best model. By the way, if you are using the scikit-learn, you should recognize this. It's a pipeline, yeah? It's scikit-learn pipeline, so there are different steps, like data normalization step, okay? Using different strategies. And you can notice, you can spot that there are more than one models being used, yeah, working together. And you can check the complete, you can download those models, use them outside Azure Machine Learning Service if you want. So it's open source and framework agnostic platform actually. Yeah, so that's something nice, I think. Okay, so that was the introduction. Now it's time to explain how I get those results, because we have like 20 minutes more. So first part is to automate data preparation. And if you think about this, actually, probably most of you who are dealing with this machine learning have a set of Python or R scripts that you are using again and again in different projects, in different scenarios. That means that the same code is being executed again and again. So that's an opportunity for automation, isn't it? So for sure, we can automatically generate some statistics. That's important. We can automatically divide data sets into train and test data sets using different strategies. We can automatically input missing values. We can detect, based on the statistics, high cardinality features and do something with them, maybe remove them automatically. The same with constants. If there is a categorical variable, we can automatically encode those features into numbers using the best, in this case, scenario. Maybe one hot, if the number of unique values is relatively low, or one hot hash encoding, if there is a lot of distinct values. Yeah, why not? There are we can embed words, so we can encode words into numbers intelligently based on the meaning, on the context of these words, of those words. We can for sure scale our numerical variable we can bin them, we can encode target as well. We can even build non-supervised models like clustering models to enhance our data sets even further. Maybe the distance between those clusters, the distances between those clusters, or the cluster numbers are important from algorithm perspective. Why not? In forecasting, for sure, we can extract a lot of information from dates, like day of week, yeah, holidays, month numbers, whatever, up to 100 or even more. And this kind of data preprocessing can be done automatically. That's my point. Now, as you can see, there are a lot of different strategies, for sure, and we don't know in advance which one is the best or will be the best for this, in this case, for this data and for this problem we are dealing with. Then, modeling part. How to choose the best algorithm? Based on intuition or previous knowledge. That's one approach. The second, maybe by chance. Yeah, because those algorithms I'm showing you right now are the most commonly used right now, actually, machine learning algorithms for classification, regression, or forecasting. All of them are available in this SDK, by the way. And actually, it's even worse. Yeah? So the problem is harder to solve because the performance of the model depends not only on data and the algorithm, but also on those hyperparameters. And now you can think about this like that. Each hyperparameter, I don't know, the learning rate or number of trees or whatever else, depends on an algorithm. You can provide a range of values, or you can select those values from distributions. It's up to you, like here. Yeah, you are defining the model architecture, and now you will get this search space of hyperparameters. Each hyperparameter is a single dimension. Yeah. And now our task is to find the best combination of those hyperparameters. That's hyperparameter optimization. This is nothing new. We are doing this for years in ML as a data scientists. But the problem is that this search space is huge. Yeah. So how to find the best hyperparameter combination? This is the first question we should know how we should answer. And 3 strategies are available. Only one is actually used, maybe 2. The first one, grid sampling, is a fancy name for brute force. So let's just check all those possible combinations. And do not use this grid sampling, okay? It's actually not that useful. Why? First, you will wait years for a result, and then majority of those models will yield very similar performance. So it's actually wasting your time and resources. Can we do better? So what about random sampling? Random sampling means easy enough to check randomly, so to check at random a few, maybe a dozen combinations across the search space. And that sounds promising. Yeah, you can do this in parallel using a lot of those nodes. Actually, the result the best model found by random sampling will be probably, in most of the cases, statistically speaking, very close to the best model found by grid sampling. It's just an optimization of this. And it's being used as a starting point to build a reference, yeah? But we can do even better. Random sampling and brute force are, let's say, they have no memory about the previous results. So they are trying those combinations without taking the previous result into account, which is silly. Why better is to use a meta model. So build a Bayesian Gaussian process model using Bayesian sampling technique. This works like the picture. You can see how it works, generally speaking, on the right side of my slide. So it's Bayesian model, the meta model that we are going to use to assess the probability that the base model, the model we are actually trying to build, will be good enough. So the objective function here is actually the performance of the base model, to put it simply. Yeah? And actually, I can use my previous attempt to find probably better combination of those hyperparameters in the next iteration. I'm taking the posterior values, so the performance of checked model, of built or trained model into account, and I'm moving from this point, not, so that's completely different strategy, and it actually works quite well. There is an additional cost for sure to build this meta model, but it's way lower than the cost of training all those base model combinations randomly. So that's Bayesian sampling on one slide, but actually we have to deal with a different problem. It's not only about hyperparameters, it's also about features. So how to clean, how to prepare data, which feature should I use? It's about algorithms and hyperparameters values. Okay, so we have to take all those things into account. So now you can think, let's start with the algorithm. You can think about an algorithm like the just additional hyperparameter, categorical one. Yeah, there will be dependencies in this hyperparameter search space right now, but we can deal with them easily. The same here. We can check, we can think about those features, so data processing techniques, as additional hyperparameters. Now, looks like we can find a better model by checking the different combinations of this AutoML pipeline, and we can automate the process. So that's the AutoML, yeah? That's the way, very promising. Actually, machines are learning from data right now automatically, and the results are very promising. And I would like to explain you two more things, and then I will switch to the notebook in which I implement my Titanic solution using AutoML, and maybe you will have some questions. So here is cache problem is combine algorithm selection and hyperparameter optimization. So this problem is the name of the problem you will find in research papers is cache. Nice, yeah. So we are solving cache problem, and here you can see the search space, but you know it's hard to show you this highly dimensional search space in PowerPoint. So instead of features or those hyperparameters or algorithm, yeah, I use latent dimension model. So it's just dimensionality reduction. I reduce this 500 or 2000 something, I don't know, dimensional space into two-dimensional space. The point is that the models or AutoML pipelines qualities are not distributed randomly here. So this region is not promising at all. Yeah. So Bayesian optimization, Bayesian sampling, if we start with here, we'll move from this area into more promising area. That's the point. Hopefully, we'll end it at somewhere here. Those combinations looks very promising, yeah? And the difference is huge. So that's the search space reduced to two dimensions, and the color is used to show you the quality of models. Yeah. Actually, you can see something like that in Azure Machine Learning Workspace. But still, if the number of dimensions is really high, Bayesian sampling is not good enough. So Bayesian sampling is commonly used for hyperparameter optimization, hyperparameter tuning. But now, if we are taking an algorithm by itself and the data preprocessing steps into account, the number of dimensions is even higher. And if we start somewhere here, it's sparse space, by the way. If we start somewhere here or here, probably we will not get to those promising areas. So how to solve this problem? And Microsoft Research found a solution. Actually, they built, we can think about this as a recommender. So recommendation machine for auto ML pipelines. It's like in Amazon, the recommendation. If you bought this book, probably you will be interested in those books as well. Or if you watch this film on Netflix, those are most promising, more interesting proposition for you. Recommendation based on key story. And Microsoft did the same, but this recommender is used to recommend the good, probably good configurations of those AutoML pipelines, okay? And they use the open data set and a lot of other data sets actually, and around thousands, millions even, those AutoML pipelines, and measure the statistic about the training data, the quality of AutoML pipeline at the end. So they have the historical data. They know more or less that for your data set and for this problem you are going to solve, you will get the best, probably the best performing AutoML pipelines somewhere here. Okay, so that's the point. That's machine meta learning. Very interesting and quite promising actually approach. And I use this. So it was just a single line of code, something like that. AutoML config. I'm doing classification. Yeah, my output, so my label is survived. Let's limit the number of trials to 10 candidates models. Let's enable futurization and wait. I did it. I got good enough results. Actually, as I said, that's the data set is very small. Yeah, so you will about 80%, from 80 to 84% of accuracy you will get by random chances actually. So that's actually state-of-the-art result to solve this specific problem, which I achieved with this. So not that much coding at all. So if you have any questions, please ask them by typing in chat. Yeah. If not, at the very end of this presentation, I will show you the code. It's actually here. Okay, so that go next. So two things are combined here: the AutoML and operationalization. So I used pipelines. So I divided my experiment into steps. The first step is this script, auto data prep. And actually, what I did during this step, I removed passenger ID. But of course, you can implement more advanced data preparations here. If you remember at the very beginning, I said probably you should combine some skills with about data preparation, and also then use AutoML. That's something. This is technical part, how to prepare this step to be launched on remote compute. No time to discuss it. Actually, out of scope of this topic. So that was it. And now you have a AutoML data preparation ready to be launched. And the AutoML step is just this one I showed you. So that's now my configuration in this case. And I even registered the model under my workspace. This is also not that important. Let me find the experiment name, and I will show you the result. So the Titanic AutoML pipeline. Okay, that's the experiment name. So let's go to experiments and search for this one. That's the one. So it actually, yeah, let's check the last run. As I said, there are 3 steps. 4 with register model, forget about this. Fetching data, data preparation, AutoML. I can publish this pipeline and use it automatically. And yeah, actually to see the metrics from here, I will have to go to a specific step. Yeah, okay. Even now, I have to go to models actually. Okay, no worries. Name equals no time to finding it like that. Titanic AutoML. So that's my what? That's not the model I wanted to show you at the end. Maybe it was somewhere else. Maybe I didn't register it even. That also may be the case. Okay, but actually, that's interesting. I forgot to register this model, obviously. So, or at least I'm unable to find it right now. No, there is more. Titanic experiment, Titanic model, but this is not the AutoML, I think. It's a pipeline type. Okay. But I showed you this registered forecasting model, so it's more or less the same experience. You have to believe me that actually that was the model I used for predictions. So no cheating here at all. And with this, it's 6 p.m. I would like to thank you very much for attending this Global AI Community Bootcamp. Hopefully you had a nice time, and See you soon, hopefully. Thank you, thank you, organizers. That's all from my side. Bye.
Thank you, Marcin.
Welcome.
And it was really a very good presentation. I would like to say again, thank you to all our speakers who joined this event. It was one good event, very good from my opinion, and we will try to continue making events on this area, AI, and hope that each next event will be better. We will continue, if it is possible, we will have events in person, but hopefully we will have hybrid events. So we will continue in a way where when it is possible, events will be in person, but we will stream these events. So thanks again also to the whole team who helped to be organized this event, especially around Stefka. And I will hope to see you again very soon. We will have different meetup events. During the summer, we are planning probably in June, if it is possible, our AI summit. And at the end of the year, we will have at least one more bootcamp. So thanks again for coming and hope to see you at the end next month, probably with the next meetup and during the summer at AI summit. Have a good evening. Bye bye.